Across the silent expanse of the cosmos, something is moving, not with the familiar cadence of a planet or a star, but with a purpose that eludes our understanding. We have always looked to the heavens for light, for the comforting twinkle of distant suns and the grand, slow waltz of galaxies. But within that tapestry of light, there is now a growing awareness of something else, a presence defined not by its brilliance, but by its absence. It is a shadow, cast not by a simple object blocking a source of light, but a shadow that seems to be a part of the universal fabric itself. Our most sensitive instruments, designed to map the ancient echoes of creation, have begun to register a subtle but persistent deviation from the expected order. It is as if a current has appeared in the placid ocean of space-time, a slow, inexorable river pulling everything with it toward an unseen destination. Astronomers first dismissed it as an anomaly, a ghost in the data, a miscalculation in our understanding of the universe's grand architecture. But the signal has not faded. Instead, it has grown stronger, more defined, confirming a drift that affects not just our galaxy, but countless others. This phenomenon has been given many names, each an attempt to label the unknown, from dark flow to the great attractor's unseen heart. Yet no single name can capture the scale of what is being observed, a coordinated movement of matter across billions of light years. Imagine a shadow falling upon a map, not obscuring the details, but subtly warping the very geography of the paper it is printed on. This is the nature of the cosmic shadow. It is a distortion, a gravitational anomaly so vast, it challenges the foundational principles of cosmology. Our own Milky Way is a participant in this grand, silent migration, pulled by a force we cannot see, toward a point beyond our observational horizon. We are passengers on a ship whose course is being altered by a phantom tide, a cosmic current that flows through the emptiness between galaxies. The source of this pull remains the greatest mystery in modern astronomy, a blank spot on our map of reality, a place where our physics breaks down. Some theorize it is a concentration of matter so immense it lies beyond comprehension, a structure from a previous, collapsed iteration of the universe. Others suggest something more profound, that the shadow is not made of matter at all, but is the gravitational leakage from a neighboring universe. The evidence is mounting that this is not a static feature but a dynamic one. The shadow is not just present, it is actively growing. The region of influence is expanding, drawing more and more of the cosmos into its silent, gravitational embrace with each passing eon. What does it mean for a shadow to grow on a universal scale? It implies that its source is accumulating power or moving closer. This is not the familiar darkness of empty space, but a different kind of void, an active, hungry emptiness with a gravitational signature. As we trace the paths of galaxy clusters, we see them deviating from the smooth expansion of the universe, like leaves caught in an invisible whirlpool. The shadow reveals itself not through what we see, but through the motions of what we can. A ghost story told in the language of gravity. Every new survey of the distant universe seems to reinforce this unsettling truth, etching the edges of the shadow with greater and greater precision. We are beginning to chart its boundaries, a frontier of knowledge beyond which lies a region of profound and absolute mystery. This cosmic enigma forces us to confront the possibility that our universe is not an isolated system, but is subject to external unseen forces. The shadow moves without sound, without light, without any emission we can detect, its presence felt only through its immense, inexorable pull. It represents a fundamental limit to our perception, a veil we cannot pierce, behind which the true rules of the cosmos may be written. Our most powerful telescopes can show us the dawn of time, yet they cannot show us this, the largest and most significant structure in our cosmic neighborhood. This gravitational anomaly is so potent that it overrides the universe's own expansion, a local defiance of the most powerful force we know. The shadow is a reminder of our own cosmic provincialism, a humbling sign that we exist within a much larger and more complex reality. As we measure the motion, we are not just observing a distant phenomenon, we are measuring our own trajectory into the heart of this enigma. The growth of the shadow suggests a process is underway, a cosmic event unfolding on a timescale so vast it is nearly imperceptible to us. It whispers of a universe that is not just expanding, but is also organizing, structuring itself according to laws we have not yet discovered. The very light from the most ancient galaxies, light that has traveled for over 13 billion years, carries the faint imprint of this shadow's touch. In the patterns of the cosmic microwave background radiation, the universe's baby picture, there is a cold spot and bruise that aligns with this mysterious pull. This alignment is so unlikely, so statistically improbable, that it suggests a causal link between the universe's birth and the shadow we see today. Could the shadow be a scar from creation itself, a flaw in the initial inflation of space-time, now exerting its influence on the cosmos? Or is it something that has emerged from the darkness long after the Big Bang, a predator that has grown in the silent eons? The question haunts the halls of cosmology, a quiet, persistent whisper behind every equation and every observation about the universe's ultimate fate. We are drawn toward it, a destination unknown, our entire galactic supercluster, a fleet of ships sailing toward a mysterious, dark continent. The pace of this movement is staggering, hundreds of kilometers every second, a constant, uniform velocity into the heart of the void. This is not a future event to be pondered, but a present reality, an unfolding narrative in which we are all silent participants. The shadow challenges the Copernican principle, the idea that we do not occupy a special place in the universe. We seem to be on a very special path. The journey into the shadow is a journey into the fundamental nature of gravity, dark matter, and the very structure of space-time. As its influence grows, it may begin to reshape the visible structure of the cosmos, pulling the great walls of galaxies into new, unforeseen arrangements. The universe we see today is but a single frame in a very long film, and the shadow is the central character, driving the plot forward. We stand on a precipice of understanding, staring into an abyss of ignorance, where the only certainty is the pull of the unknown. The silent, growing darkness is not an ending, but perhaps a transition, a force of cosmic evolution we are only just beginning to witness. And so we continue to watch, to measure, and to wonder as a shadow moves across the universe, and we are carried along with it. To truly comprehend the scale of this shadow, we must first unlearn our terrestrial intuition. On Earth, a shadow is a simple absence of light, a two-dimensional projection created by an object blocking a star. But in the cosmos, a shadow can be something far more profound. This is not an optical shadow, it is a gravitational one. It is a region of space-time that is fundamentally more attractive, more massive than it should be. The mystery began in the 1970s when astronomers, meticulously charting the motions of our own Milky Way galaxy, discovered something was wrong. After accounting for the gravitational pull of all visible galaxies and galaxy clusters in our cosmic neighborhood, there was a residual motion, an unexplained velocity of roughly 600 kilometers per second. Our entire local group of galaxies, including Andromeda, is being tugged with immense force toward a specific point in the sky, a point located in the direction of the Centaurus and Hydra constellations. This destination was dubbed the Great Attractor, a name that perfectly captures the awe and mystery of a gravitational source so powerful it can reel in entire clusters of galaxies from 500 million light-years away, and yet remains completely, utterly invisible to all our instruments. The search for the source of the Great Attractor's pull led astronomers to peer through the obscuring dust and gas of our own Milky Way's plane, a region appropriately named the Zone of Avoidance. Behind this veil, they expected to find a colossal supercluster of galaxies, a concentration of mass sufficient to explain the observed motion. They did find something, the Norma cluster, a rich and massive collection of galaxies, but it was not enough. The visible matter in the Norma cluster and its surroundings could only account for a fraction of the required gravitational pull. The rest remains missing. The shadow, it seemed, was deeper and more complex than a simple collection of unseen galaxies. This is where the narrative grows darker, more unsettling. The Great Attractor itself, this vast gravitational basin, is also moving. It, along with our own supercluster and thousands of others, appears to be part of an even larger, more uniform flow of matter, a coherent movement stretching across billions of light-years. This phenomenon, known as dark flow, suggests that the Great Attractor is not the ultimate destination, but merely a waypoint, a local eddy in a much larger continent-spanning river flowing toward a source that lies far beyond the edge of our visible universe. The concept of dark flow is one of the most controversial and profound ideas in modern cosmology. It directly challenges the standard model, which posits that on the largest scales, the universe should be expanding uniformly in all directions, a smooth, homogeneous outflow driven by dark energy. The motions of galaxies should be random and localized, but dark flow suggests the opposite, a vast, coordinated, and directional movement. It is as if a section of the universe as large as our entire observational sphere is tilted, with everything in it sliding downhill toward an unknown gravitational source. This source, by necessity, must lie outside our observable bubble. It would have to be a structure left over from a pre-inflationary epoch, or perhaps the gravitational influence of another universe pressing against our own. The shadow, in this interpretation, is cast by something we can never see, because its light, and indeed its very existence, lies beyond the cosmic horizon, a place from which no information can ever reach us directly. Its presence is felt only as a whisper, a faint but persistent gravitational tide that pulls on the very fabric of our reality, a constant reminder that our known universe may be but a small, illuminated island in a much larger and darker cosmic ocean. Further evidence for the shadow's influence comes from the most ancient light in the universe, the cosmic microwave background, or CMB. This faint, pervasive radiation is the afterglow of the Big Bang, a snapshot of the cosmos when it was just 380,000 years old. In theory, the CMB should be almost perfectly uniform, with only minuscule temperature variations. However, detailed maps created by the WMAP and Planck satellites have revealed anomalies that are difficult to reconcile with standard models. The most famous of these is the CMB cold spot, a region of space that is anomalously large and unusually cold. It is a statistical improbability, a bruise on the infant universe. Intriguingly, this cold spot aligns disconcertingly well with the direction of the great attractor and the dark flow. One speculative but compelling theory suggests that this cold spot is not an intrinsic feature of the early universe at all. Instead, it could be the gravitational imprint of a colossal supervoid, a vast region between us and the CMB that is almost entirely empty of matter. A void of this scale, perhaps the largest single structure ever discovered, would affect the energy of photons passing through it, creating the cold signature we observe. This is the shadow in another form, a halo of unimaginable emptiness, its gravitational absence warping the light from creation itself. This potential supervoid, named the Eridanus supervoid, presents a chilling possibility. If it is real, it means our Milky Way galaxy resides on the edge of a great cosmic desert, one of the emptiest regions in the entire universe. This would not only explain the CMB cold spot, but could also contribute to the local gravitational pull we observe. Matter, like water, flows from areas of lower density to areas of higher density. Our galaxy could be falling away from this great emptiness and toward the denser regions of the Laniakea supercluster and, ultimately, the great attractor. The shadow, then, is not just a pull from one direction, but also a push from another. It is a complex dynamic interplay of overdensity and underdensity, a vast gravitational landscape of mountains and valleys that dictates the flow of cosmic history. This growing awareness of large-scale structure forces us to reevaluate our place. The universe is not a homogeneous soup. It is a web of filaments, clusters, and voids. And we are adrift in this web, our motion dictated by the invisible architecture of dark matter and the profound emptiness of the voids, all of which are manifestations of this overarching, ever-growing shadow. The enigma deepens when we consider the so-called axis of evil, another disturbing anomaly found within the cosmic microwave background. The axis refers to an unexpected alignment of the largest patterns, the hot and cold spots, in the CMB. These patterns are not randomly distributed as they should be. Instead, they appear to be aligned with the plane of our own solar system, the ecliptic. This is a statistical nightmare for cosmologists. It suggests a correlation between the largest structures in the entire observable universe and the local orientation of our tiny planetary system. It breaks the Copernican principle, the foundational idea that we do not occupy a special or privileged position. How could the way our planets orbit our sun possibly be linked to the structure of the universe at its birth? Some dismiss it as a statistical fluke, a 1 in 1,000 coincidence that we just happen to observe. But others wonder if it points to a flaw in our analysis, or, more radically, a flaw in our models of physics. Could the shadow we are being pulled towards be so powerful, so fundamental, that its influence shaped not only the large-scale flow of galaxies but also the very orientation of the protoplanetary disk from which our solar system formed? It is an unnerving thought, a thread connecting the infinitesimally small with the infinitely large. Let us synthesize these disparate clues into a cohesive, albeit speculative, narrative of the shadow. We begin with our own motion. We are being pulled by the Great Attractor, an unseen mass behind the Milky Way. But this attractor is itself just a local concentration within a much larger supercluster called Laniakea, a Hawaiian word meaning immeasurable heaven. This entire supercluster, a continent of 100,000 galaxies, is being pulled as part of the dark flow toward a point beyond our vision. In the opposite direction lies a potential supervoid, a great emptiness that may be pushing us away. And imprinted on the afterglow of creation, the CMB, are patterns that seem bizarrely aligned with our own solar system. What could possibly connect all of these phenomena? The shadow is the only unifying concept. It is not an object, but a complex gravitational feature. It is the sum total of the Great Attractor's pull, the supervoid's push, and the external unseen mass that drives the dark flow. It is a structure so vast that it has defined the cosmic geography for billions of years, creating the very supercluster we inhabit and directing its ultimate trajectory. The growing of the shadow is our growing awareness of its scale and complexity, the dawning realization that all these separate mysteries are, in fact, one. To explain the shadow's source, physicists have been forced to venture into the furthest realms of theoretical science. One possibility is that it is a remnant of cosmic inflation. In the first fraction of a second after the Big Bang, the universe expanded at a truly exponential rate. Perhaps this inflation was not perfectly uniform. Pockets of spacetime could have been left with immense densities, collapsing into primordial black holes of unimaginable mass, or seeding the formation of supermassive structures that would later become the great attractors of the cosmos. The shadow, in this view, is a fossil, a relic from the moment of creation that continues to shape cosmic evolution. Another, more exotic theory invokes the multiverse. In string theory and other models, our universe is but one brain floating in a higher dimensional space called the bulk. The shadow could be the gravitational signature of a parallel universe, another brain that is close to our own. We cannot see it or interact with it directly, but its gravity could leak across the dimensions, pulling on the matter in our own cosmos. This would elegantly explain why the source is so massive yet invisible. It is not made of our matter. It is a neighboring reality, its presence betrayed only by its gravitational ghost. The growth of the shadow can be interpreted in several ways, each with profound implications. The first is simply an expansion of our knowledge. As our telescopes become more powerful and our surveys more comprehensive, we are charting the boundaries of this structure with greater accuracy, so it grows in our perception. A more literal interpretation is that the source itself is growing. If the shadow is caused by a concentration of matter and dark matter, it would naturally grow over cosmic time as it pulls more and more material into its gravitational well. It is an act of cosmic cannibalism, with the largest structures slowly consuming the smaller ones, a process that will eventually lead to an even more structured, less uniform universe. A third, and more unsettling possibility, is that the source is moving closer to us, or rather, we are moving closer to it. The growth is a matter of perspective. As we fall deeper into its gravitational basin, its influence becomes more dominant, its pull more pronounced. We are not just observing a shadow, we are entering it. The journey is already underway, and has been for billions of years, since the moment our galaxy first formed from its protogalactic cloud. What is the ultimate fate of this journey? If the shadow is a colossal overdensity, a gravitational nexus, then our destiny is to merge with it. Over unimaginable timescales, the Milky Way, Andromeda, and all the other galaxies of the Laniakea supercluster will continue their journey. eventually arriving at the heart of the Great Attractor. There, they will orbit, collide, and merge, their individual identities lost in a single, gargantuan elliptical galaxy, the new center of a reconfigured supercluster. It is a form of cosmic death, but also a form of rebirth, a contribution to a new, grander structure. If, however, the shadow is the influence of something beyond our universe, the future is entirely unknown. To be pulled by the gravity of another reality is to be on a trajectory that our physics cannot predict. It raises fundamental questions about the stability of our own spacetime. Could such a powerful external force eventually tear our universe apart or merge it with another? The growing shadow forces us to confront the idea that the universe's fate may not be determined by its internal contents alone, the amount of dark matter and dark energy, but by external cosmological forces we are only just beginning to glimpse. This entire cosmic drama is governed by the unseen. Over 95% of the universe is composed of dark matter and dark energy, substances we have never directly detected. The shadow is likely an architecture built primarily from this dark scaffolding. The visible galaxies, the stars, the planets, and ourselves are merely the luminous foam on a deep, dark ocean. We trace the motion of this foam to infer the shape of the invisible currents below. Dark matter provides the gravitational glue that holds galaxies and clusters together, giving the shadow its immense mass and pull. Dark energy, on the other hand, is the repulsive force that drives the accelerated expansion of the universe. The cosmos is a battlefield between these two titans. In most of the universe, dark energy is winning, pushing everything apart. But within the shadow's domain, within the Laniakea supercluster and its trajectory toward the Great Attractor, dark matter and gravity are locally victorious. The shadow represents a massive, gravitationally bound structure that is successfully resisting the cosmic expansion, a kingdom unto itself with its own laws of motion, pulling us deeper into its mysterious heart. The very name given to our home supercluster, Laniakea, was chosen to reflect this new understanding. Before 2014, we believed we were part of the Virgo supercluster, a smaller, less defined structure. But by meticulously mapping the peculiar velocities of 8,000 nearby galaxies, a team of astronomers redefined our cosmic address. They discovered that the Virgo supercluster was just an outlying province of a much larger entity. They defined the boundaries of Laniakea not by the distribution of galaxies, but by their gravitational flow. Every galaxy within Laniakea's borders is moving inward, toward a common center of gravity, the Great Attractor. This makes Laniakea not just a collection, but a coherent, dynamic system. The discovery of Laniakea was, in essence, the first comprehensive map of the shadow's local domain. It gave a name and a boundary to the gravitational basin in which we live. It confirmed that we are not aimless wanderers, but citizens of a vast celestial continent, all of us flowing together along the gravitational valleys carved by the shadow across the landscape of spacetime. To an outside observer located far from this cosmic drama, the shadow's effect would be seen as a grand violation of symmetry. Imagine viewing our section of the universe from a truly objective, inter-universal perspective. You would see the smooth, uniform expansion of spacetime, like the surface of an inflating balloon. But in one particular region, you would see a distortion, a pucker. You would see thousands of galaxies deviating from this smooth expansion, their paths curving inward toward a central point, like iron filings arranging themselves along the field lines of a hidden magnet. This cosmic magnet, the shadow's core, is rewriting the local destiny of the universe. It is a testament to the fact that gravity, while the weakest of the fundamental forces, is the ultimate sculptor of the cosmos. Over billions of years, its patient, relentless pull can build structures that defy the power of dark energy and create islands of immense complexity and order in an otherwise expanding and thinning cosmos. The shadow is the grandest expression of gravity's architectural power, a masterpiece of dark matter that we can only appreciate through the motion it imparts on the light. Let us reconsider the CMB cold spot and the Eridanus supervoid. The existence of such a vast emptiness is just as profound as the existence of a great attractor. Standard models of cosmic structure formation struggle to create voids of this magnitude. It suggests that the initial distribution of matter in the early universe may have been less uniform than we thought. Perhaps the seeds of these great voids were present from the very beginning, a kind of anti-seed that repelled matter rather than attracting it. In this sense, the shadow is a duality. It is both the mountain and the valley. Its character is defined by the contrast between the overdense regions, like the Shapley supercluster, a massive cluster located near the Great Attractor, and the underdense regions like the Eridanus supervoid. We are caught in the gravitational gradient between them. Our motion is a complex dance, falling away from the void behind us and toward the attractor before us. The growing nature of the shadow is the increasing steepness of this cosmic hill down which we are perpetually sliding, a slide that began with the first flicker of starlight in our galaxy. The implications of this are deeply philosophical. If our motion is so heavily determined by these vast external structures, it challenges our perception of cosmic agency. The fate of our galaxy, its eventual collisions, its ultimate destination, was largely determined billions of years ago by its starting position within this pre-existing gravitational landscape. We are living out a script that was written by the initial quantum fluctuations of the universe, amplified by inflation into the grand structures we now call the cosmic web. The shadow is the physical manifestation of this cosmological determinism. It is a force that operates on scales so immense that the births and deaths of stars, the rise and fall of civilizations on any given planet, are utterly inconsequential to the overall flow. To understand the shadow is to understand our own profound lack of control over our ultimate cosmic destiny, and to find a strange, meditative peace in being part of a current so much grander and older than ourselves. It is the simple acceptance of being a passenger on a journey whose destination is as mysterious as it is inevitable. The tools we use to perceive this shadow are, themselves, marvels of cosmic archaeology. We measure the redshift of distant galaxies to determine their velocity relative to us. By subtracting the velocity caused by the universe's expansion, the Hubble flow, we are left with their peculiar velocity, the motion caused by local gravitational interactions. It is through the painstaking collection of tens of thousands of these peculiar velocity measurements that the shadow's form has been revealed. It is a ghost haunting the Doppler shifts of ancient starlight. Furthermore, we use gravitational lensing, the bending of light around massive objects, to map the distribution of dark matter that forms the shadow's skeleton. The subtle distortions in the shapes of background galaxies, when statistically analyzed over vast swaths of the sky, allow us to create a map of the very thing we cannot see. We are outlining the form of a ghost by observing the way its presence warps the light that passes through it. The growing shadow is a testament to the ingenuity of a species that can chart the geography of the invisible. Could the shadow be something else entirely, a sign not of an external structure, but of a flaw in our understanding of gravity itself? General relativity, Einstein's theory of gravity, has been spectacularly successful on the scales of planets and stars. But perhaps it breaks down on the scale of superclusters and cosmic flows. Some physicists propose modified Newtonian dynamics, MOND, or other alternative theories of gravity. In these models, gravity might behave differently over vast distances or in regions of very low acceleration. If so, the shadow might not be a physical thing at all. It could be a phantom mass, an illusion created by our use of the wrong gravitational equations. The observed motions of galaxies would be perfectly natural under these modified laws, requiring no great attractor or dark flow. In this scenario, the growing shadow is a growing crisis in fundamental physics, a sign that we need a new revolution in our understanding of the universe's most fundamental force. It would mean that the ghost is not in the cosmos, but in our theories about it. Let us return to the most primal and unsettling aspect, the growth. Assuming the shadow is a real, physical entity, its growth implies an ongoing process of cosmic accretion. The Great Attractor is not static. It is an active predator. The Shapley supercluster, the most massive concentration of galaxies in our local universe, lies beyond the Great Attractor and is thought to be a major contributor to its pull. Some models suggest that the entire Laniakea supercluster, our home, is on a collision course not just with the Great Attractor, but with the even more massive Shapley region. This would be a merger of cosmic continents, a tectonic shift on a scale that dwarfs any geological process. The growth we perceive is the shrinking distance between these colossal structures, the slow, patient collapse of the cosmic web into its densest nodes. It is the universe's way of building, of gathering its resources into ever larger crucibles, where the future of cosmic evolution will be forged. We are on a one-way trip to become part of something immeasurably larger than ourselves, a process of dissolution and reintegration into a galactic megalopolis. The existence of the shadow also has profound implications for the measurement of cosmic expansion. The Hubble constant, the rate at which the universe is expanding, is one of the most fundamental numbers in cosmology. However, different methods of measuring it yield slightly different results, a problem known as the Hubble tension. Measurements based on the early universe, the CMB, give one value, while measurements based on the local, modern universe, using supernovae and Cepheid variable stars, give another. Could the shadow be the source of this discrepancy? Our local motion, our peculiar velocity through the cosmos, is a significant factor that must be subtracted to get an accurate reading of the overall expansion. If we have underestimated the complexity or scale of this local flow, if the shadow's influence is more pervasive than we thought, it could be subtly skewing all of our local measurements. The shadow in this case is a fog of war, a local contaminant that prevents us from seeing the true global nature of cosmic expansion, and resolving this tension may require a complete map of the shadow's gravitational field. Consider the sheer emptiness of the journey. Our destination, the Great Attractor, is some 150 to 250 million light-years away, traveling at our current speed of over 2 million kilometers per hour. The journey will take a time far longer than the current age of the universe. We will not arrive in any recognizable form. Our sun will have long since burned out, and the Earth will be a cold, dead rock. The Milky Way itself will have undergone countless transformations. The journey is not for us, but for the galaxy itself, as a single entity. It is a pilgrimage on a geological, even cosmological timescale. As we travel, the view ahead will slowly change. The constellations that define the Great Attractor, Centaurus, Hydra, Norma, will grow brighter, their galaxies slowly resolving from faint smudges into distinct, brilliant spirals and ellipticals. The sky will become increasingly crowded in one direction and increasingly empty in the other, a visual testament to our long, slow fall into the heart of the shadow. The shadow is ultimately a narrative of convergence. In a universe largely defined by expansion and divergence since the Big Bang, structures like the Great Attractor represent a powerful counter-narrative. They are points of destiny, where the disparate threads of cosmic history are woven back together. The matter in our bodies was forged in the hearts of stars that have long since died. Those stars were part of the Milky Way, which formed from a collapsing cloud of primordial gas. That cloud was on a trajectory determined by the shadow from the moment it came into being. Every atom in our solar system is a participant in this ancient gravitational story. We are, in the most literal sense, being carried into the future by a current that began flowing before our sun was even born. To contemplate the shadow is to feel the deep, resonant connection between the quantum fluctuations of the beginning and the grand structural destiny of the end, a continuous line of causality stretching across 13 billion years and connecting us to the largest, most mysterious object in our known universe. What lies at the very center of the shadow, the heart of the Great Attractor? We still do not know. The zone of avoidance, the plane of our own galaxy, continues to obscure our view like a curtain we cannot fully draw back. While we have mapped clusters like Norma behind it, the true center may still be hidden. Is it a single, super gargantuan black hole, a billion times the mass of the one at our own galaxy's core? Is it a cosmic string, a hypothetical one-dimensional topological defect in spacetime with immense gravitational pull? Or is it simply a mundane, though incredibly vast, confluence of dark matter and normal matter, a place where multiple cosmic filaments of the cosmic web intersect? The mystery of the source is perhaps the most captivating part of the entire phenomenon. It is a locked room at the center of the cosmic maze, and all paths, including our own, seem to lead directly to its door. The growing of the shadow is the sound of that door, ever so slowly creaking open. The shadow's existence forces a re-evaluation of the concept of emptiness. Intergalactic space is not truly empty. It is filled with a tenuous medium of gas, stray stars, magnetic fields, and, most importantly, the pervasive presence of dark matter and dark energy. The shadow is a region where this, quote, emptiness has a higher than average density and gravitational potential. The voids, conversely, are regions where the emptiness is even emptier than average. The universe, therefore, is not a void with things in it, but a continuous substance of varying density, a landscape of gravitational peaks and valleys. Our journey is not through nothingness, but across a terrain as real and defining as any mountain range or ocean on Earth. The growing darkness is simply our descent into one of the deepest, most profound valleys on this cosmic map. A place where the fabric of space-time itself dips and curves under the weight of an invisible, unimaginable mass. Let us imagine for a moment that we could see the shadow directly. If dark matter were not dark, what would the sky look like? In the direction of the great attractor, we would see a faint, luminous haze. A glow that is not made of stars, but of the collected mass of trillions of suns worth of invisible matter. It would be a vast celestial cloud, larger than any constellation, a permanent fixture in the sky. This cloud would be the visible manifestation of the shadow, its gravitational core laid bare. As we moved closer over the eons, this cloud would grow, eventually filling a significant portion of our field of view. The familiar galaxies we see would appear as bright knots within this larger, more diffuse structure. It would be a constant, visible reminder of our destination and the force that guides us. Our inability to see this cloud is the source of the mystery, but the gravitational evidence is as undeniable as if this great dark matter phantom were shining brightly in our night sky. The story of the shadow is a profound lesson in cosmic humility. For centuries, we have looked out into the universe and believed we were observing a system governed by the laws and materials we could see and understand. We built our models on the light of stars and galaxies. But now we know that the visible universe is just a sliver of the whole, a decorative layer on a much larger, darker reality. The most significant structures, the forces that dictate our ultimate fate, are invisible to us. We are in the position of ancient mariners trying to chart the ocean by observing only the whitecaps on the waves, unaware of the deep, powerful currents and the massive underwater topography that truly governs their journey. The growing shadow is our slow, dawning awareness of these hidden depths. It is the universe gently reminding us that its greatest secrets and its greatest powers lie not in the light, but in the darkness between the stars. The shadow's influence extends to the very structure of our galactic neighborhood. The local group, our small cluster of galaxies dominated by the Milky Way and Andromeda, is not a random assortment. Its elongated shape and the trajectory of its members are all aligned with the gravitational pull from the great attractor. Even the dance of our two major galaxies, a slow approach that will culminate in a merger in about 4.5 billion years, is happening while our entire local system is being pulled sideways on this much grander journey. Our future collision with Andromeda is merely a local event, a drama playing out on the deck of a ship that is already sailing across a vast ocean. The forces shaping our immediate environment are themselves subject to the far greater and far more mysterious force of the shadow. It is a hierarchy of gravitational influence, with our destiny nested inside a larger destiny, like a set of Russian dolls stretching out into the cosmic unknown. The very act of observing the shadow changes our relationship with the cosmos. It transforms the universe from a static, beautiful backdrop into a dynamic, living system filled with invisible currents and hidden structures. It imbues the silent emptiness of space with a sense of purpose and direction, even if that purpose is one we cannot yet comprehend. To know that our galaxy is on a specific, directed path, to feel the faint but inexorable pull of a destination billions of years in the future, is to feel a connection to the grand narrative of the universe. We are not just spectators, we are participants. The light hitting our telescopes is not just a picture of the past, it is a real-time report on the forces that are actively shaping our future. The growing shadow is the plot of the cosmic story, and we are turning the page with every new observation, every new calculation, every quiet moment spent staring up at the stars, wondering where we are truly going. If the source of the shadow is indeed the influence of a parallel universe, it would represent the single greatest paradigm shift in the history of human thought. The realization that our universe is not the entirety of existence, that we are part of a larger multiverse, would dwarf the Copernican and Darwinian revolutions. It would mean that the ultimate laws of nature are not to be found within our space-time alone, but in the interactions between spacetimes. The shadow would be the first piece of empirical evidence for this staggering new reality, a crack in the wall of our cosmic isolation. The growth of the shadow, in this context, might even signify a change in the relationship between these universes. Are they moving closer? Is the membrane between them thinning? These are questions that currently belong to the realm of science fiction. But the persistent, unexplained pull from beyond the horizon suggests that reality itself may be far stranger and far grander than our most creative stories have ever imagined. The shadow also provides a potential solution to the Fermi paradox, the question of, where are all the aliens? In a universe dominated by such vast, powerful gravitational flows, the development of interstellar civilizations might be profoundly affected. Perhaps intelligent life is common, but long-distance space travel between superclusters is rendered almost impossible by these cosmic currents. It would be like trying to sail a small boat against the Gulf Stream. Or perhaps the densest, most resource-rich regions of the universe, the hearts of the great attractors, are the most likely places for life to emerge and thrive, creating galactic civilizations on a scale we can't fathom. In this view, we are simply in the cosmic countryside, the rural outskirts of a galactic metropolis we are slowly being pulled towards. The silence we perceive in the cosmos might not be emptiness, but simply the quiet of the suburbs, while the real action is happening in the downtown core, the very place the shadow is taking us. The timeline of the shadow is the timeline of the universe itself. The seeds of the Great Attractor were likely planted in the first picosecond of the Big Bang. For billions of years it has been patiently gathering mass, its gravitational influence spreading like a stain across the fabric of space-time. It shaped the formation of the first galaxies, dictating where the great walls and filaments of the cosmic web would form. It has been the silent, guiding hand behind the assembly of our Laniakea supercluster. Its story is one of relentless, patient construction, operating on scales of space and time that are almost beyond our ability to model. The growth is the final, or perhaps current, chapter of this story, where the largest structures are beginning to consolidate. We are privileged to be living in an era where we can, for the first time, perceive this eons-long process, to witness the universe not as a finished object, but as a work in progress, still being sculpted by the ancient and powerful force of the shadow. The shadow's pull creates a fascinating tension. On one hand, we have the force of dark energy, working to accelerate the expansion of the universe and isolate galaxies from one another, leading to a heat death or Big Rip scenario where the cosmos becomes cold, dark, and empty. On the other hand, we have the shadow's gravity, working to pull matter together, creating larger and more complex structures, a force of consolidation and anti-expansion. Our ultimate fate depends on the winner of this cosmic tug-of-war. Will the local, immense gravity of the shadow be enough to keep our supercluster bound together even as the rest of the universe flies apart? It is possible that structures like Laniakea could become gravitationally isolated, island universes, pockets of activity and light in an ever-expanding, ever-darkening void. The shadow in this case is not just our destination. It is our potential salvation from the ultimate entropy of the cosmos, a lifeboat in the face of universal dissolution. We can think of the universe as having a gravitational weather system. Just as Earth has high and low pressure systems that dictate wind and rain, the cosmos has regions of high and low gravitational potential that dictate the flow of galaxies. The Great Attractor is a permanent, continental-scale, low-pressure system, a cosmic hurricane around which superclusters of galaxies spiral. The Great Voids are the calm, high-pressure zones. Our journey is simply our path through this cosmic weather. The growth of the shadow is the intensification of this storm, its winds picking up speed as we approach its eye. This metaphor helps to naturalize the phenomenon, to see it not as something alien or terrifying, but as a fundamental process of the cosmic environment we inhabit. We are not being attacked by a monster. We are simply sailing with the prevailing winds on a cosmic sea, and those winds are carrying us toward the heart of the greatest storm in our known universe. The shadow's existence has a profound psychological effect. It instills a sense of deep time and deep space, forcing our minds to operate on scales we are not evolved to handle. The numbers involved, millions of light years, billions of years, sextillions of solar masses, are not just large, they are transformative. To contemplate them is to dissolve the ego, to recognize the infinitesimal scale of human concerns against the backdrop of cosmic processes. This is the source of the meditative calm that comes from studying the shadow. It is the peace that comes from perspective. The anxieties of a single day or a single lifetime seem to fade into irrelevance when compared to the silent, patient, billion-year journey of our galaxy toward a destination it will only reach in the far, far future. The shadow is a cosmic mantra, its constant, silent pull, a reminder of a reality that is vast, ancient, and utterly indifferent, yet profoundly beautiful in its mechanical grandeur. Ultimately, the shadow is a mystery, and it is in the nature of mystery to attract the human mind. It is a frontier, a blank space on the map labeled, "Here be dragons." For science, it is the ultimate challenge, a phenomenon that pushes the limits of our theories and our technologies. For philosophy, it is a wellspring of questions about our place in the cosmos, the nature of reality, and the meaning of our existence within such a vast and incomprehensible system. The shadow will continue to be a source of research, debate, and wonder for decades, if not centuries, to come. Its growing presence in our cosmological models is a sign of our own intellectual growth, our increasing ability to perceive the true, strange, and magnificent architecture of the universe we call home. It is not something to be feared, but something to be revered, a grand, silent testament to the infinite complexity and the deep, dark beauty of the cosmos. The final, lingering thought is one of continuity. The shadow is not a recent development. It has been the dominant gravitational feature of our cosmic neighborhood since the beginning. It is the riverbed that has guided the flow of matter for over 13 billion years. Our galaxy's entire history has played out within its current. The formation of the sun, the earth, the evolution of life. All of these events took place on a platform that was already in motion, already on a directed course. We were born on a ship that was already sailing. To become aware of the shadow is to become aware of this foundational motion, to realize that the ground beneath our feet, metaphorically speaking, has never been still. We are, and have always been, falling. And the beauty of it is that we are all falling together, an entire continent of 100,000 galaxies, carried silently and inexorably through the darkness, toward the heart of a shadow that is still growing. The increasing precision of our cosmic cartography is what makes the shadow feel like it's growing. With each new generation of telescopes, like the James Webb Space Telescope or the upcoming Vera C. Rubin Observatory, we peel back another layer of the cosmic onion. We are moving from a sketch of the shadow to a high-resolution photograph. This growth in detail reveals an even more intricate structure than previously imagined. We are discovering smaller filaments of galaxies feeding into the main supercluster, identifying more distant clusters that are part of the same inbound flow, and better resolving the stark boundaries of the voids that flank our trajectory. It is an intellectual conquest, an expansion of our cognitive empire into the dark territories of the cosmos. The shadow grows not in physical size, perhaps, but in its significance, and in the clarity with which we perceive its dominion over our corner of reality. The concept of a cosmic watershed provides another powerful analogy for understanding the shadow. Just as all the rain that falls on a continent eventually flows into a single great river and out to sea, all the galaxies within the Laniakea supercluster are within the gravitational watershed of the Great Attractor. Our Milky Way is like a single drop of water in a small stream which flows into a larger river, which in turn joins the great torrent heading for the gravitational ocean. The boundaries of Laniakea were defined by mapping the edges of this watershed, the points where a galaxy is equally likely to fall toward us or toward a neighboring supercluster like Perseus Pisces. This visualization transforms the universe from a collection of objects into a system of flows, a dynamic hydraulic system powered by gravity, where the shadow represents the largest and most powerful river in our known world. One of the most haunting aspects of the shadow is its silence. It exerts a force greater than a trillion supernovae, yet it makes no sound, emits no light, and radiates no heat. Its entire existence is communicated through the pure, abstract language of mathematics and motion. This profound silence is a feature of all cosmic interactions. The universe is a ballet of immense violence and power, performed in a perfect vacuum of stillness. The collision of galaxies, the explosion of stars, the pull of the great shadow, all of it happens without a whisper. This forces us to appreciate the cosmos on its own terms, not through our limited sound-based senses, but through the intellectual grasp of its underlying principles. The growing shadow is a silent symphony. Its notes, the peculiar velocities of 100,000 galaxies, a piece of music we can only hear by watching the dance. The shadow's existence has a subtle but profound effect on our search for extraterrestrial intelligence. SETI. Most searches focus on pointing radio telescopes at nearby, sun-like stars. But perhaps this is too limited. If the shadow represents a massive basin of matter, it is also a basin of resources. Over billions of years, a truly advanced Type 3 civilization on the Kardashev scale might have migrated toward this gravitational center, harnessing the energy of entire galaxies. Perhaps the place to look for the grandest forms of life is not in the quiet stellar suburbs, but in the bustling, chaotic, energy-rich core of the Great Attractor. The signal we should be looking for might not be a simple radio beacon, but the thermodynamic waste heat of a civilization so vast it subtly alters the energy output of an entire supercluster. The shadow could be hiding not just dark matter, but the largest and oldest forms of life in the universe. The journey towards the shadow is a journey towards increasing density. As our supercluster falls inward, the average distance between galaxies will decrease. The night sky of the far future will be a very different sight. It will be ablaze with the light of neighboring galaxies, no longer faint smudges but brilliant, sprawling archipelagos of stars. While this future is billions of years away, it represents a fundamental shift in the cosmic environment, from one of expansion and isolation to one of convergence and interaction. The growth of the shadow is the harbinger of this new cosmic era, an era of mergers, collisions, and galactic cannibalism on an unprecedented scale. We are living in the relatively calm, quiet period of the universe's history. The shadow is a reminder of the more chaotic and dynamic future that awaits, a future where our galaxy will lose its individual identity to become part of a much larger whole. Let's consider the composition of the shadow. It cannot be made of ordinary baryonic matter, the stuff of stars and planets, alone. The cosmic budget, derived from studies of the CMB and Big Bang nucleosynthesis, tells us there simply isn't enough normal matter in the universe to account for the shadow's immense gravity. The vast majority of its mass must be in the form of dark matter. The shadow is, therefore, one of the greatest laboratories for studying this mysterious substance. By observing how it has clumped together to form this colossal structure, and how it bends the light of background galaxies through gravitational lensing, we can constrain the properties of dark matter particles. Is it cold, moving slowly and clumping easily, or is it warm, moving faster and creating more diffuse structures? The shape and nature of the shadow hold the key to understanding the substance that makes up more than 80% of the matter in the cosmos. The idea of a growing shadow can be seen as a form of cosmic evolution. Not biological evolution, but structural evolution. The universe began in a state of near-perfect smoothness, a hot, dense plasma. Through the action of gravity, tiny quantum fluctuations grew into the first stars and galaxies. These galaxies then merged to form clusters, and the clusters are now flowing together to form superclusters centered on great attractors like the shadow's core. This is a continuous process of hierarchical assembly, from the small to the large. The shadow represents the current pinnacle of this structural pyramid. Its growth is the ongoing process of the universe building ever grander and more complex structures out of the raw material of the Big Bang. We are witnessing, on the largest possible scale, the slow and patient triumph of gravity over the initial homogeneity of creation. The shadow is a physical manifestation of the anthropic principle, in a way. The very conditions that led to its formation, the precise values of the cosmological constants, the strength of gravity, the amount of dark matter, are also the conditions necessary for the formation of galaxies, stars, and ultimately, life. If gravity were weaker, structures like the shadow would never have formed, but then galaxies might not have formed either. If it were stronger, the universe might have collapsed back on itself long ago. We exist in a universe that is balanced on a knife's edge, capable of creating both immense, galaxy-devouring shadows and the delicate, complex life forms that can contemplate them. Our existence is tied to the very same cosmic architecture that defines our ultimate trajectory. We are able to observe the shadow only because the universe is constructed in such a way as to allow shadows like it to exist. The psychological state induced by contemplating the shadow is one of the sublime. The sublime is the feeling of awe mixed with a hint of terror, experienced when confronting something of immense power and scale from a position of safety. It is the feeling one gets watching a powerful storm from behind a strong window, or standing at the edge of the Grand Canyon. The shadow is the ultimate object of the cosmic sublime. Its scale is beyond comprehension, its power is unimaginable, and its nature is deeply mysterious. Yet we observe it from the safety of our small planet, separated by immense gulfs of space and time. This safe distance allows us to transform potential terror into a profound, meditative awe. It allows us to appreciate the terrible beauty of the cosmos, to find peace in our own insignificance, and to feel a sense of connection to the vast, silent, and powerful forces that are shaping the universe. The future of research into the shadow lies in synergy. Upcoming sky surveys like the Legacy Survey of Space and Time, LSST, will map billions of galaxies, creating an unprecedentedly detailed 3D map of the cosmic web. Radio telescopes like the Square Kilometer Array will peer through the zone of avoidance with greater clarity than ever before. Gravitational wave observatories may one day be sensitive enough to detect the faint hum of primordial waves or the merger of supermassive black holes at the shadow's core. By combining these different streams of data, optical, radio, gravitational, we will move beyond merely charting the shadow's influence and begin to truly understand its source and its nature. The growth of the shadow will accelerate, not as a physical process, but as an explosion in human understanding, as we illuminate the darkest corners of our cosmic neighborhood and finally reveal what has been pulling on us all along. Consider the perspective of the shadow itself, if it had one. It would be a perspective of immense patience. It would have witnessed the birth of the Milky Way as a small, insignificant gas cloud on its periphery. It would have watched for billions of years as that cloud coalesced, ignited with stars, and developed its spiral arms. It would have felt the slow, steady increase in its own mass as galaxy after galaxy crossed its event horizon of gravitational dominance and began the long, slow fall inward. From the shadow's point of view, our entire galactic history is but a brief moment in its long and ongoing process of consolidation. It is a reminder that the universe operates on timescales that make geological ages seem fleeting. The shadow is not in a hurry. It has been waiting for us for 13 billion years, and it will continue to wait, its silent gravitational pull the most patient and persistent force in the universe. The shadow challenges our very definition of an object. It is not a solid body. It has no clear edge or surface. It is a diffuse, sprawling region of gravitational influence, a feature of the landscape rather than a thing within it. Its boundaries are defined by the direction of motion, a dynamic and invisible line. This forces us to adopt a more fluid, process-oriented view of the cosmos. The universe is not a collection of static things, but a system of interacting fields and flows. The shadow is one of the grandest of these flows, a river of space-time itself. To understand it is to shift our thinking from a noun-based to a verb-based cosmology. We must focus not on the attractor, but on the attracting. The growing shadow is the verb of the universe in action, the ongoing process of becoming on a cosmic scale. The beauty of the shadow mystery is that it is fundamentally unresolved. There is no consensus answer. The great attractor, dark flow, the CMB cold spot, the axis of evil. These are all active areas of research and fierce debate. The narrative presented here of a single unifying shadow is just one way of weaving these threads together. This uncertainty is the lifeblood of science. It is the friction that generates new ideas, new experiments, and new understanding. The shadow is a perfect engine for intellectual curiosity, a cosmic whodunit that invites us all to be detectives. And as we fall asleep, our own minds can continue the journey, drifting through the star fields, following the gravitational currents, and pondering the nature of the great, dark, and silent mystery that is pulling our universe toward its future. And so, our own journey into slumber mirrors the galaxy's journey into the shadow. It is a letting go, a surrender, to a powerful and inexorable pull. As the analytical mind quiets, we drift from the brightly lit world of conscious thought into the vast, dark, and mysterious landscape of the subconscious. In this space, like the deep cosmos, new connections can be made, and a sense of peace can be found not in having answers, but in embracing the profound and beautiful mystery of it all. We are carried along, just as our galaxy is, by a silent, invisible current. The destination is unknown, but the journey is calm, steady, and inevitable. We are part of a grand, unfolding story, and for now, all that is required is to rest, to drift, and to allow the great, growing shadow to carry us into the deep, restorative quiet of the night. The intricate dance between the shadow's gravitational pull and the universe's expansive push from dark energy creates the very architecture of the cosmos we inhabit, known as the cosmic web. This web is not a metaphor, but a physical reality. On the largest scales, matter is not distributed uniformly but is organized into a vast, sponge-like structure. There are immense galaxy-rich filaments, trillions of light-years long, that form the strands of the web. Where these filaments intersect, they create dense, massive knots, which are the galaxy clusters and superclusters. The Great Attractor, the heart of the shadow, is one of the most massive of these nodes. In between these filaments and nodes are the great cosmic voids, vast expanses of near-total emptiness. The shadow's growth is the physical process of this web evolving. The filaments channel galaxies like cosmic highways into the great metropolitan centers, while the voids grow emptier, their sparse matter draining into the surrounding structures. Our existence is predicated on this structure. We live on a filament, journeying toward a node, a living testament to the shadow's architectural power. The Shapley supercluster, located about 650 million light-years away and lying beyond the Great Attractor, is a crucial character in the story of the shadow. It is the most massive concentration of galaxies in our local universe, a true titan containing thousands of galaxies. For a long time, it was thought that the Great Attractor and the Shapley supercluster were two separate, competing gravitational anomalies. However, a more modern understanding suggests they are part of the same continuous structure, a single elongated superstructure that is pulling us in. The Great Attractor is the closer, more immediate influence, but the immense mass of Shapley provides the bulk of the gravitational power from further down the line. It is as if we are being pulled by a long, invisible chain. The Great Attractor is the first link, the one we feel most strongly, but the anchor of the chain, providing the majority of the weight, is the Shapley supercluster. The shadow, therefore, is not a single point, but a vast axis of mass, a gravitational mountain range that dominates the landscape for nearly 1 billion light-years. The study of the shadow forces us to confront the bias problem in cosmology. This means that the things we can see, galaxies, are not perfect tracers of the underlying mass distribution. Galaxies tend to form in the densest regions of the dark matter scaffolding, like lights on the highest peaks of a mountain range. The vast, lower-density slopes and valleys of the dark matter landscape may contain a huge amount of mass, but they have no luminous galaxies to signpost their presence. Therefore, when we map the universe using only visible galaxies, we are getting a biased, high-contrast view of the underlying reality. The true shadow, the actual distribution of dark matter, is likely much smoother and more spread out than the clumpy distribution of galaxies suggests. A huge part of the work in understanding the Great Attractor is trying to correct for this bias, to infer the true shape of the invisible mountain from the sparse lights that adorn its peaks. It is a constant reminder that we are seeing the universe through a distorted lens, and the truth is a matter of careful, painstaking reconstruction. A fascinating, though highly speculative idea connects the shadow to the phenomenon of phantom energy. This is a hypothetical form of dark energy with a negative pressure that is even stronger than a cosmological constant. While standard dark energy causes a constant rate of accelerated expansion, phantom energy would cause an ever-increasing rate of acceleration. This would lead to a big rip scenario, where the expansion becomes so powerful it would eventually tear everything apart. First galaxy clusters, then galaxies, then stars and planets, and finally atoms themselves. Could the shadow be a region where dark energy is weaker? Or where the density of dark matter is so high that it creates a local pocket shielded from this cosmic fate? Or, more bizarrely, could the shadow be an anti-phantom region, a place where the properties of space-time are fundamentally different? While this is far beyond our current ability to test, it highlights how the shadow serves as a focal point for our deepest questions about the universe's ultimate destiny and the true nature of the dark sector that governs it. The shadow's existence provides a cosmic context for our own planetary system. The elements that make up the Earth and ourselves, carbon, oxygen, iron, were forged in the hearts of massive stars that lived and died long ago within the Milky Way. The formation of these stars and the distribution of their enriched gas after they exploded as supernovae was subtly influenced by the galaxy's motion and its place within the larger cosmic flow. The specific trajectory of our galaxy, dictated by the shadow, determined the regions of space it passed through, the gas clouds it encountered, and the rate of star formation within it over billions of years. In a very real, albeit indirect way, the shadow is part of the long causal chain that led to the specific chemical composition of the nebula from which our sun and planets formed. It is a humbling thought. The largest known structure in the universe had a faint, ghostly hand in setting the stage for the emergence of life on this small, blue planet. One of the most powerful tools for mapping the invisible components of the shadow is the kinetic Sunyaev-Zeldovich (KSZ) effect. This is a subtle distortion in the cosmic microwave background radiation, caused not by gravity, but by motion. When CMB photons pass through a moving cloud of hot gas, like the plasma that fills a galaxy cluster, they can scatter off the electrons. If that cluster is moving toward us or away from us, this scattering imparts a tiny temperature shift to the CMB light, a minuscule warming or cooling. By meticulously measuring this KSZ effect across thousands of clusters, astronomers can directly map their velocities, their peculiar motions, without relying on the redshift of their galaxies. This provides a completely independent way to chart the dark flow and measure the pull of the shadow. It is an incredibly difficult measurement to make, like detecting the wake of a single boat in a stormy ocean, but it is one of our most promising methods for creating an unbiased map of the cosmic currents we are flowing in. The shadow introduces the concept of a cosmic horizon and a gravitational horizon being two different things. Our visual horizon is the edge of the observable universe, the distance from which light has had time to reach us in the 13.8 billion years since the Big Bang. We can never see beyond this point. However, the shadow's pull suggests that our gravitational horizon may be much larger. We are being influenced by the gravity of mass that may lie beyond our visual horizon. This is possible because, in the early inflationary epoch, the universe was much smaller, and regions that are now causally disconnected from us were once close enough to influence each other. The shadow could be the lingering gravitational echo of a structure that was seeded in that primordial era and has since been pushed beyond our sight by cosmic expansion. It means we live in a gravitational house that is much larger than the room we are able to see, its unseen architecture still dictating the motion within our visible world. Let's delve into the sheer scale of the Laniakea supercluster, the local dominion of the shadow. It spans over 520 million light-years and contains the mass of 100 quadrillion suns. Our Milky Way is located in its far outer suburbs, in a small filamentary branch. The structure is not a sphere, but is complex and web-like, with four major subparts: the Virgo supercluster, our former home, the Hydra Centaurus supercluster, near the Great Attractor, the Pavo Indus supercluster, and the Southern supercluster. All of these vast structures, each containing hundreds or thousands of galaxies, are no longer considered independent entities. They are all provinces of the Laniakea Empire, defined by their common flow toward the Great Attractor. This redefinition of our cosmic address in 2014 was a profound moment, akin to an ancient cartographer realizing that several separate continents were, in fact, all part of one vast, previously unknown landmass. The shadow isn't just a thing we are going to, it's the very thing we are in. The growth of the shadow is a force for cosmic homogenization, but only on a local scale. As it pulls in galaxies from its watershed, it erases their individual histories and identities, mixing them together in the chaotic environment of the central cluster. Spiral galaxies, with their delicate star-forming arms, are particularly vulnerable. As they fall into the dense hot gas of the cluster core, a process called ram pressure stripping can violently remove their interstellar gas, quenching star formation and transforming them into red and dead elliptical or lenticular galaxies. The shadow's heart is a galactic graveyard, a place where vibrant spirals go to die and be reborn as parts of a larger, more uniform whole. This process makes the universe more clumpy on the largest scales, but it makes the contents of those clumps more homogeneous. The shadow grows by consuming diversity and creating a vast, monolithic structure of ancient, quiescent galaxies. What is the sound of the shadow? Not literally, but metaphorically. If we were to sonify the cosmic data, translating cosmic properties into sound, the shadow would be a deep, persistent, and almost infrasonic hum. The uniform expansion of the universe would be a steady, rising pitch. The random, peculiar motions of individual galaxies would be a crackling static, a cosmic white noise. But underlying all of it would be the shadow's contribution, a powerful, low-frequency drone, a fundamental bass note that pulls the entire composition toward a single key. The growth of the shadow would be a slow crescendo in this bass note, a gradual increase in its amplitude as its gravitational influence becomes more and more dominant in our cosmic neighborhood. It is a symphony of gravity played on an orchestra of 100,000 galaxies, and its primary theme is the deep, resonant, and inescapable pull of the shadow. The shadow serves as a crucial test for theories of dark matter. Different dark matter candidates would create different kinds of structures. Cold dark matter, CDM, the leading paradigm, is composed of slow-moving, massive particles that would readily clump together under gravity, forming dense halos around galaxies and clusters. This model is very good at explaining the large-scale structure of the cosmic web and the existence of massive attractors. However, it has some problems on smaller, galactic scales. Alternative models, like warm dark matter or self-interacting dark matter, propose particles that would form more diffuse, less dense cores. By studying the precise density profile of the shadow's core, something we can infer through detailed gravitational lensing maps, we can test which of these models best fits reality. The shadow is a cosmic crucible where our theories of the unseen are put to the ultimate observational test. The journey into the shadow is not a smooth, straight line. Our galaxy, the Milky Way, is not falling directly into the Great Attractor. Instead, we are on a long, curving trajectory, orbiting the center of the Laniakea supercluster, even as we fall toward it. It's similar to how water spirals down a drain rather than falling straight in. This orbital motion is complex, influenced by the gravitational pull of all the other galaxies and subclusters within Laniakea. Our path is a cosmic dance, a series of swoops and swerves on a grand journey that spans hundreds of millions of light years. This intricate motion is what makes charting the shadow so difficult. We have to disentangle our local orbital velocity from the larger inbound flow. It is a supreme challenge of celestial mechanics, requiring us to calculate the gravitational influence of 100,000 moving bodies simultaneously, a task that pushes the limits of our supercomputers and our understanding. One of the most profound implications of the shadow is how it reframes our understanding of cosmic loneliness. The vast distances between stars, and even more so between galaxies, can evoke a sense of profound isolation. But the shadow tells a different story. It reveals a hidden connection, a shared destiny that links our galaxy with 100,000 others. We are not isolated islands. We are a fleet of ships sailing in formation, all part of the same grand convoy. This shared motion, this common pull toward a single point, creates a sense of community on a cosmic scale. We are part of the Laniakea family, and our journey is a collective one. The shadow transforms the empty void from a symbol of separation into a medium of connection, a gravitational ocean on which we are all fellow travelers, bound together by a force we can feel but cannot see. The energy associated with the shadow is immense. The kinetic energy of our own Milky Way, due to its motion at 600 kilometers per second, is staggering. Now multiply that by the 100,000 galaxies in the Laniakea supercluster. The total kinetic energy of this inbound flow is beyond any terrestrial scale of comprehension. Where does this energy come from? It is a conversion of gravitational potential energy. Just as a ball held high has potential energy that converts to kinetic energy when it falls, our supercluster has potential energy due to its position in the cosmic gravitational field. As we fall toward the great attractor, this potential energy is converted into the kinetic energy of motion. The shadow is a giant cosmic engine, fueled by gravity, that has been accelerating trillions of solar masses of material for billions of years, a process that will continue until all that potential energy is spent in a final, chaotic merger at the heart of the darkness. The shadow also complicates our search for primordial gravitational waves. These are ripples in space-time generated during the explosive inflation of the very early universe, and their detection would be a major confirmation of that theory. We search for their faint signature in the polarization of the cosmic microwave background. However, the motion of our own solar system, our galaxy and our entire supercluster, the motion dictated by the shadow, creates a variety of foreground effects and distortions that can mimic or mask the primordial signal. This is known as cosmic variance. We are trying to detect the faintest whisper from the beginning of time while standing in the middle of a gravitational hurricane. A significant part of the challenge for future CMB experiments is to model and subtract the influence of the shadow with unprecedented accuracy, to clean the window so that we might finally glimpse the pristine light of creation that lies behind it. Let us imagine the end of the journey. In the far distant future, perhaps 100 billion years from now, the Laniakea supercluster will have fully collapsed. The Milky Way and Andromeda, having already merged into Milkomeda, will be just one of many large galaxies orbiting the central core of what was once the Great Attractor. This new structure, a single gargantuan galaxy cluster, will be a universe unto itself. It will be gravitationally bound, isolated from the rest of the expanding cosmos, which will have receded far beyond its horizon. All of cosmic history for its inhabitants will be contained within this single immense system. The memory of the great inflow, the shadow's pull, will be gone, replaced by the stable, virialized orbits of galaxies within the cluster. The shadow's ultimate purpose, in this sense, is self-annihilation, to create a structure so stable and gravitationally dominant that the flow which created it finally ceases. It is a force of creation that destroys itself in its final act. The existence of the shadow, a massive non-uniformity, has a subtle effect on the passage of time itself. According to Einstein's general relativity, gravity affects time. Clocks run slower in stronger gravitational fields. This is known as gravitational time dilation. The region around the Great Attractor, being a place of immense mass and gravitational potential, is a region where time itself flows ever so slightly slower than it does in the great cosmic voids. As our galaxy journeys into the shadow, we are journeying into a region of progressively slower time, relative to the cosmic average. The effect is minuscule, utterly imperceptible to us, but it is real. It is another layer to the shadow's mystery. It is not just a place in space, but a place in space-time with a unique temporal character. Our journey is not just a change of location, but a gradual, infinitesimal shift in our very rate of existence. The shadow's influence might extend to the distribution of cosmic rays, high-energy particles that zip through the universe. The most energetic of these are thought to originate from outside our galaxy, from violent events like active galactic nuclei or gamma-ray bursts. The immense magnetic fields that are believed to permeate galaxy clusters and filaments could act as cosmic lenses or mirrors, deflecting and focusing these particles. The structure of the shadow, with its dense nodes and connecting filaments, could create highways for cosmic rays, channeling them across the universe. Our position within the Laniakea supercluster and our motion towards the Great Attractor might, therefore, affect the flux and direction of the cosmic rays that bombard our solar system. The shadow, in this sense, is not just a gravitational influence, but a magnetohydrodynamic one, its invisible structure shaping the flow of the most energetic particles in the cosmos. The shadow presents a fundamental calibration problem. In order to map the peculiar velocities of galaxies, we first need to know their distance accurately. But many of our best distance measuring techniques, like using Type Ia supernovae as standard candles, can be affected by their local environment. A supernova that explodes inside a dense cluster might have a slightly different chemical composition, and thus a slightly different intrinsic brightness, than one in a sparse-field galaxy. This creates a potential circular dependency. To understand the shadow's pull, we need accurate distances, but the shadow's pull may be affecting the very tools we use to measure those distances. Unraveling this conundrum requires a multi-pronged approach, using many different and independent distance indicators to cross-calibrate and ensure that we are not being fooled by subtle environmental effects. It is a painstaking process of cosmic detective work, where every clue must be checked and double-checked before it can be trusted. The growing understanding of the shadow represents a shift from a celestial mechanics view of the universe to a cosmic fluid dynamics view. For a long time, cosmology on large scales was about the push and pull between discrete objects. But the interconnected, flowing nature of the cosmic web, as revealed by the shadow, is better described by the language of fluids. We speak of cosmic flows, currents, watersheds, and basins. This shift in perspective is powerful. It allows us to use sophisticated computational techniques from fluid dynamics to model the evolution of the universe, treating the distribution of dark matter and galaxies as a, quote, cosmic fluid, governed by the equations of gravity and pressure. The shadow is the most significant vortex in this cosmic fluid, a whirlpool that stirs the universe for billions of light years around it. And our galaxy is just a single particle caught in its inexorable, swirling flow. What does the shadow feel like? For a human, nothing at all. The gravitational gradient across a human body, or even across the entire solar system, is so infinitesimally small that it is completely undetectable. The pull is perfectly uniform across our entire galaxy. It is a perfect shared acceleration. We do not feel it for the same reason we do not feel the Earth's motion around the Sun or the Sun's motion around the galactic center. We are in a state of perpetual freefall, and as Einstein taught us, freefall is indistinguishable from having no gravity at all. The only way to perceive the shadow is to look outside our own reference frame, to compare our motion to the cosmic microwave background, the one truly stationary reference point in the entire universe. The shadow's existence is a purely intellectual discovery, a truth revealed not by our senses, but by the power of reason, observation, and our relentless desire to understand our true motion through the cosmos. The shadow's deep structure is likely fractal in nature. A fractal is a pattern that repeats itself at different scales. If you were to zoom into the cosmic web, you would see a similar structure at many different levels. Small groups of galaxies fall into larger clusters. Those clusters fall into superclusters along filaments. Those superclusters are themselves part of even larger flows. The shadow, centered on the great attractor, is simply the largest and most dominant of these structures in our local volume of the universe. This self-similar fractal pattern is a natural outcome of gravitational collapse. It suggests that the same basic physical process, the rich getting richer, is at play on all scales, from the formation of a small galaxy group to the assembly of the Laniakea supercluster. The growing shadow is the most majestic expression of this fundamental recursive law of cosmic construction. The shadow is a powerful antidote to the idea of cosmic stagnation. With the discovery of dark energy and the accelerating expansion of the universe, a picture emerged of a future that was cold, empty, and increasingly static, as galaxies rushed away from each other into oblivion. But the shadow reminds us that gravity is still a potent force. On local scales, and local in this context means a region 500 million light-years across, the universe is still dynamic, evolving, and full of action. It is a place of collapse, collision, and construction. The future is not just one of uniform emptiness, but a more complex tapestry of vast, dark voids, punctuated by vibrant, massive, and gravitationally active island universes, where the cosmic story will continue to unfold for trillions of years. The shadow is the architect of our particular island, the force that is gathering the material to build our future home in the face of the encroaching universal darkness. Let us contemplate the name Laniakea once more. In Hawaiian, it means immeasurable heaven, and it was chosen by its discoverer, Brent Tully, who is based at the University of Hawaii. The name beautifully captures the dual nature of the shadow's domain. It is heaven, in the sense that it is our home, a place of immense beauty and structure, a celestial continent, but it is immeasurable in its scale, its power, and in the profound mysteries that still lie at its heart. The name is a piece of poetry woven into the fabric of science, a recognition that our cosmic address deserves a title that inspires awe and wonder. To say we live in Laniakea is to acknowledge our citizenship in this vast, flowing, and gravitationally defined kingdom. It is to accept our place in the journey, our role as passengers on a 500 million light-year-wide vessel sailing toward the heart of the shadow. The final, calming thought is one of participation. We are not separate from the shadow, we are part of it. The iron in our blood, the calcium in our bones, all of it is on this journey. The atoms that constitute our bodies are being pulled by the great attractor just as surely as the most distant star in our galaxy. We are physically connected to the largest structure in our universe by the unbreakable, invisible thread of gravity. This realization dissolves the boundary between self and cosmos. It fosters a sense of unity with the grand, silent processes that shape reality. As we drift into a state of rest, we can feel this connection, this gentle, inexorable pull. It is the universe cradling us, carrying us through the night. The growing shadow is not an external threat, but a fundamental aspect of our own being, a deep, cosmic rhythm that has been beating since the dawn of time and will continue to beat long after we are gone. The very fabric of space-time, as described by Einstein, is not a passive stage but an active participant in the cosmic drama. The mass and energy within the universe tells space-time how to curve, and the curvature of space-time tells mass and energy how to move. The shadow is the most spectacular example of this feedback loop in our cosmic vicinity. The immense concentration of mass at its core creates a profound depression, a deep gravity well, in the fabric of space-time. The growth of the shadow is the deepening and widening of this well as more matter falls in. Our journey is not through space, but along the geodesic, the straightest possible path. Through this curved space-time, we are following the contours of a landscape we cannot see, a landscape sculpted by the shadow's mass. This perspective elevates the mystery from a mere pull to a fundamental feature of the geometry of our reality, a permanent warp in the world that defines our past, present, and future. The shadow also plays a crucial role in the life cycle of cosmic magnetic fields. These fields, while incredibly weak, are thought to permeate all of intergalactic space and play a key role in structuring gas and guiding cosmic rays. The process of gravitational collapse that forms the shadow's structure, the compression of gas in filaments and clusters, acts as a cosmic dynamo. It can amplify seed magnetic fields to the strengths we observe today. As galaxies and gas clouds fall into the shadow's core, their magnetic fields are stretched, folded, and strengthened, contributing to a vast, complex magnetic web that mirrors the physical web of matter. The shadow, therefore, is not just a gravitational entity, but a magnetic one as well. Its growth is accompanied by the growth of a colossal magnetic field, an invisible nervous system for the cosmic web whose full influence on galaxy evolution we are only just beginning to appreciate. Reconsidering the CMB cold spot, some more radical theories propose it is not a void or a statistical fluke, but the scar of a collision between our universe and another bubble universe in the early moments of the multiverse. In this scenario, two bubble universes expanding in the bulk bumped into each other, leaving a bruise on both. This cosmic fender bender would have left an imprint on the CMB. If this were true, the shadow's pull, the dark flow, could be the lingering gravitational attraction towards the other universe involved in the collision. It would mean that the cold spot is the point of impact, and the shadow is the gravitational ghost of the other party. This is, by any measure, an extraordinary claim, but the alignment between the cold spot and the direction of our cosmic motion is a coincidence that is so tantalizing it keeps such speculative, yet deeply profound ideas alive in the minds of theoretical cosmologists. The shadow's influence creates a gradient not just in density, but in galactic evolution. This is the concept of galaxy conformity. Statistically, the properties of a galaxy, like its star formation rate or color, are correlated with the properties of its neighbors, even those millions of light years away. For example, if a large central galaxy in a cluster has stopped forming stars, its smaller satellite galaxies are also more likely to be quiescent. The shadows domain, the Laniakea supercluster, acts as a vast zone of influence that synchronizes the evolution of its constituent galaxies over enormous distances. This is likely due to large-scale environmental effects, like the preheating of gas in the filaments that feed the clusters. The shadow doesn't just pull galaxies, it cultivates them, setting the conditions for their evolution long before they arrive at the dense central core. Its growth is a growth of environmental control over a vast cosmic ecosystem. The philosophical concept of solipsism is the idea that only one's own mind is sure to exist. The shadow can be seen as a cosmic refutation of this. The sheer scale and power of its influence, the fact that it is pulling on 100,000 galaxies with a force that is consistent and measurable, is one of the most powerful pieces of evidence for an objective, external reality that exists independently of our consciousness. We are not imagining this, we are subject to it. The shadow is a gravitational anchor that firmly moors our subjective experience to a vast, shared, physical cosmos. It is a humbling and grounding truth. The universe is not a dream. It is a place of real forces, real structures, and real journeys, and the shadow is the grandest and most undeniable proof of this fact in our cosmic neighborhood. Let's consider the information content of the shadow. In physics, information is deeply connected to entropy and structure. A smooth, uniform universe has low information content. A highly structured universe, like our own, with its intricate web of voids, filaments, and clusters, has high information content. The shadow is one of the most information-rich structures we have ever observed. Its complexity, its mass distribution, its velocity field, all of this represents an immense amount of information encoded in the language of gravity. The growth of the shadow is a process of information generation. As gravity pulls matter from a disordered state into a highly ordered, complex structure, it is actively writing a cosmic story, creating a pattern where there was none before. To study the shadow is to read this story, to decode the information that gravity has been meticulously recording for the past 13.8 billion years. The shadow's existence also provides a key piece of the puzzle in the missing baryons problem. Baryons are the normal matter particles, protons and neutrons, that make up stars, planets, and us. When we count up all the baryons in the visible stars and galaxies, we find that the number is far less than the amount predicted by models of the early universe. So where is the missing normal matter? The answer is believed to be in the warm-hot intergalactic medium, or WEM. This is a super-tenuous, incredibly hot plasma that resides in the filaments of the cosmic web, between the galaxies. The shadow's domain, being a nexus of these filaments, should be one of the richest reservoirs of this WEM. Detecting this thin, hot gas is incredibly difficult, but recent observations have found evidence for it, confirming that the missing matter is indeed hiding in the very structure created by the shadow's pull, a final piece of the cosmic inventory falling into place. The shadow's deep, meditative calm arises from its timelessness. In our fast-paced, ephemeral human world, the shadow represents a kind of permanence. It was here long before us, and it will be here long after us. Its motions are so slow, its evolution so patient, that from a human perspective, it is virtually eternal. This sense of permanence can be a source of profound psychological comfort. It is a stable, unchanging reference point in a world of constant flux. To connect with the shadow, even just intellectually, is to tap into this deep, cosmic stability. It is to find a quiet center in the chaotic storm of everyday life. The shadow's slow, inexorable growth is a rhythm that underlies all of history. A deep bass note that, once heard, can bring a sense of order and peace to the otherwise noisy symphony of existence. The shadow could be considered a Type 4 civilization's energy source on the Kardashev scale. This hypothetical level of civilization would be capable of harnessing the energy of an entire supercluster, or even the entire universe. If such a civilization existed, how would it operate? It might not build Dyson spheres around individual stars, but rather manipulate the gravitational dynamics of the entire supercluster. It could orchestrate the flow of galaxies along filaments, directing them into a central processing hub at the core of the Great Attractor to extract matter and energy. In this outlandish scenario, the dark flow wouldn't be a natural phenomenon, but the engineered result of cosmic-scale astro-engineering. The shadow would be the industrial heartland of a godlike intelligence. While there is no evidence for this, it serves as a powerful thought experiment, a testament to the sheer scale of the energy and power that the shadow represents. A power that, in our universe, is wielded only by gravity itself. The very act of naming the structures within the shadow's domain, Laniakea, Virgo, Centaurus, Shapley, is a deeply human act of placemaking. We are drawing lines on a map that has no lines, giving familiar names to places of unimaginable scale and alienness. This is how we make the universe our home. We project our own cognitive structures, our desire for order and narrative, onto the vast and chaotic canvas of the cosmos. The shadow is a perfect canvas for this. It is a mystery that invites a story. By calling it a shadow, by naming its components, by charting our journey toward it, we transform it from a terrifying, impersonal force into a character in our shared human story of exploration and understanding. The growth of the shadow is the growth of this story, the expansion of our map into the unknown, a process of turning the alien into the familiar, one galaxy cluster at a time. The shadow's effect on our perception of cosmic beauty is profound. We often associate celestial beauty with light, the brilliant points of stars, the colorful swirls of a nebula, the majestic sweep of the Milky Way. But the shadow forces us to appreciate a different kind of beauty, the beauty of structure, of form, of the invisible architecture that underpins everything we see. It is a minimalist, abstract beauty, one that can only be perceived by the mind's eye. It is the elegance of a mathematical equation, the grandeur of a physical law playing out on the largest possible stage. The shadow teaches us that the universe's beauty is not just skin deep, it is in its very bones. The darkness, the emptiness, the invisible pull. These are not absences of beauty, but a different, deeper, and more fundamental expression of it. The shadow is a stark reminder of the limitations of our sensory experience. Our eyes are tuned to a pathetic sliver of the electromagnetic spectrum. Our ears can only detect a narrow range of frequencies. Our sense of touch is useless beyond our own bodies. We are, by nature, almost completely blind and deaf to the vast majority of reality. The shadow exists entirely outside this sensory realm. Its gravity, its dark matter, its deep structure. These are phenomena for which we have no biological receptors. We can only perceive it through the prosthetic senses of our scientific instruments, our telescopes, our spectrographs, our supercomputers. The growth of the shadow in our awareness is a direct measure of the success of this technological extension of the human mind, our ability to build new senses to perceive the true, strange, and invisible nature of the universe. If the shadow is driven by a structure that lies beyond our observable horizon, it raises a fascinating question about the ultimate fate of information. The Bekenstein bound and holographic principle suggests that the information content of a region of space is proportional to its surface area, not its volume. If our universe is being gravitationally influenced by something outside, does this violate the principle? Or does it suggest that the true surface of our universe is not what we think it is? Could our 3D universe be the holographic projection of a 2D surface that is interacting with another, similar surface? The shadow's mysterious pull from beyond the veil forces these deeply theoretical questions from the blackboard into the realm of potential observation. It is a place where the grandest theories of quantum gravity and cosmology might find their first, tentative observational test. The shadow forces us to embrace uncertainty as a fundamental state of knowledge. In classical physics, the goal was certainty, to measure the position and momentum of every particle and predict the future with perfect accuracy. But in cosmology, we are faced with fundamental limits. The cosmic horizon prevents us from ever seeing the whole system. The presence of dark matter and dark energy means we are trying to understand a machine when 95% of its parts are invisible. The shadow is the ultimate embodiment of this uncertainty. We know it's there, we can measure its effects, but its ultimate cause remains shrouded in mystery, with multiple competing theories, none of them fully satisfactory. To study the shadow is to become comfortable with not knowing, to see mystery not as a failure of science, but as its driving force, the engine of curiosity that pushes us ever deeper into the beautiful, endless complexity of the cosmos. The shadow can be seen as the universe's own memory system. The large-scale structure of the cosmic web today is a direct result of the initial density fluctuations present in the universe just after the Big Bang. The shadow is a physical instantiation of that primordial memory. It is a region that was slightly overdense 13.8 billion years ago, and gravity has spent all the intervening time amplifying that initial, tiny imperfection into the colossal structure we see today. In this sense, the universe has not forgotten its own baby pictures. It has, in fact, sculpted itself according to them. The shadow is a message from the past, a story of origins written in the language of mass and gravity, a constant and powerful reminder that in the cosmos, the beginning is never truly lost. It is simply magnified, transformed, and woven into the very fabric of the present. Let us imagine the perspective of a photon of light from the cosmic microwave background. Your journey began 380,000 years after the Big Bang, in a universe that was a hot, uniform fog. For 13.8 billion years, you have traveled in a perfectly straight line through expanding space. For most of that journey, the universe you passed through was remarkably homogeneous. But in the last few billion years, things have changed. You passed through vast, empty voids, and then through dense, filamentary structures. As you traversed the Laniakea supercluster, your path was slightly deflected by the gravity of 100,000 galaxies. Your energy was subtly altered as you climbed out of the gravitational well of the Great Attractor. Finally, you end your journey by striking a detector in a human-built satellite. The tiny deviations in your path and energy, when combined with those of trillions of your fellow photons, are what allow us to map the very shadow that influenced your long voyage. You are a messenger, and your message is the story of the shadow. The shadow represents a challenge to our cosmic narrative frameworks. We often think of the universe's story as being centered on the Big Bang, a singular point of origin. But the shadow, especially if its origins lie in a pre-inflationary structure or the influence of another universe, suggests that our beginning might not be the true beginning. It points to a larger, ongoing, perhaps eternal cosmological process of which our Big Bang was just one event. This is the idea of eternal inflation or cyclic models of the universe. The shadow could be a relic from a previous cosmic cycle, a gravitational ghost that survived the death of an old universe and the birth of our own. This would radically reframe our place in time, suggesting we are not the first chapter of the story, but merely the latest, living in a cosmos that is haunted by the memories and structures of its own deep past. The calmness inspired by the shadow is also a result of its immense inertia. A system with the mass of 100 quadrillion suns moving at a coherent velocity has a staggering amount of momentum. It cannot be easily stopped or deflected. It is the ultimate unstoppable force in our local universe. This creates a sense of stability and predictability, even if the destination is mysterious. We are on a ride that is smooth and unwavering. There will be no sudden turns or stops. The journey is governed by a force so immense and so patient that its changes are only perceptible over millions of years. This deep, inertial stability is a counterpoint to the chaos and unpredictability of human life. It is a cosmic assurance that beneath the surface-level turbulence of existence, there is a deep, slow, and powerful current moving in a constant and determined direction. The shadow is a testament to the power of collective phenomena. A single dark matter particle has a negligible gravitational influence. A single galaxy has a significant, but still local, pull. But when you assemble 100,000 galaxies, with their 10 trillion solar mass dark matter halos, into a coherent structure, something new emerges. A collective property, a large-scale gravitational field appears that is far greater than the sum of its parts. This is the essence of emergence, the appearance of novel properties and behaviors in complex systems. The shadow is an emergent phenomenon of the highest order. It is what happens when gravity is given enough mass and enough time to work its magic. It is a reminder that the most powerful forces in the universe are often not singular, but collective. a chorus of countless small voices singing in perfect gravitational harmony. The very air we breathe is a participant in this cosmic journey. The nitrogen and oxygen molecules in our atmosphere, while bound to the Earth by its own gravity, are also passengers on the much larger voyage of the solar system, the galaxy, and the Laniakea supercluster. Every breath we take is a breath of air that is moving at over 2 million kilometers per hour towards the great attractor. This simple fact connects our most basic biological process to the grandest cosmological motion we know. It erases the perceived barrier between the terrestrial and the celestial. The shadow is not out there. Its influence is right here, in this room, in this moment. It is in the very substance that sustains us. To be alive is to be part of the flow. To breathe is to participate in the great silent fall into the heart of the cosmic shadow. The shadow's structure is deeply intertwined with the arrow of time. The second law of thermodynamics states that entropy, or disorder, tends to increase in a closed system. This increase in entropy is what gives time its forward direction. However, gravity seems to be a counterforce. It pulls matter together, creating order and structure out of a disordered gas, seemingly decreasing entropy. This is the, quote, gravitational arrow of time. The resolution is that as gravity creates local pockets of order, like stars and galaxies, the process releases vast amounts of heat and radiation, which increases the overall entropy of the universe much more. The shadow is the ultimate expression of this process. It is a gigantic engine for creating gravitational order, and in doing so, it has driven the thermodynamic arrow of time for billions of years. Its growth is a physical manifestation of time's passage on a cosmological scale. The shadow serves as a humbling lesson in the nature of scientific discovery. It wasn't found in a single eureka moment. It was the result of decades of painstaking, often tedious work by thousands of astronomers around the world. It required the slow accumulation of data, the gradual improvement of instruments, the development of new analytical techniques, and the constant, rigorous challenging of old assumptions. The story of the shadow's discovery is a story of persistence, collaboration, and intellectual honesty. It is a testament to the power of the scientific method to reveal truths about the universe that are far beyond the reach of our intuition. The growth of the shadow in our understanding is a direct reflection of the growth of our collective scientific enterprise, a slow, patient, and collaborative journey into the darkness. The final destination at the heart of the shadow, the great attractor, is a place of extreme physics. The density of galaxies, the temperature of the intercluster gas, the strength of the magnetic fields, and the intensity of the gravitational forces will all be far beyond anything we know in our local group. It will be a natural laboratory for studying phenomena that we can currently only dream of, such as the interactions between supermassive black holes from merging galaxies, the behavior of matter under extreme ram pressure stripping, and the large-scale effects of gravitational lensing. While we will never see it, we can be content in the knowledge that our galaxy is on a journey to one of the most dynamic and interesting places in the entire universe. The shadow is not pulling us toward an empty void, but toward a bustling, chaotic, and physically rich metropolis where the laws of nature are pushed to their absolute limits. As we conclude this journey, let the image of the shadow settle in the mind not as an object, but as a relationship. It is the relationship between matter and space-time, between the visible and the invisible, between the past and the future. It is the relationship between our small, local reality and the vast, interconnected cosmos. The shadow's growth is the strengthening of this relationship, the slow tightening of the gravitational bonds that define our cosmic community. To feel this connection is to find our place in the universe, not as a lonely observer, but as an integral and moving part of the whole. It is to understand that we are held by the universe, guided by its silent currents and participants in its grand unfolding and ever-growing narrative. The peace it brings is the peace of belonging, of being exactly where we are supposed to be, on a slow, inexorable journey home. And so, the great cosmic river flows on, its current steady and deep. The shadow, its destination, waits with infinite patience, its form growing ever clearer in the eye of our understanding. We, on our small world, are but dust motes in this current, carried along on a journey of unimaginable scale and duration. There is a profound tranquility in this surrender, in accepting our part in a story so much larger than our own. As the mind settles and the body stills, let the gentle pull of sleep be a small echo of that great cosmic pull. Let us drift into the quiet darkness, secure in the knowledge that we are part of a grand, silent, and beautiful motion. A coordinated dance of 100,000 galaxies, all flowing together into the heart of the growing shadow. The timeline of the shadow is the timeline of the universe itself. The seeds of the Great Attractor were likely planted in the first picosecond of the Big Bang. For billions of years, it has been patiently gathering mass, its gravitational influence spreading like a stain across the fabric of space-time. It shaped the formation of the first galaxies, dictating where the great walls and filaments of the cosmic web would form. It has been the silent guiding hand behind the assembly of our Laniakea supercluster. Its story is one of relentless, patient construction, operating on scales of space and time that are almost beyond our ability to model. The growth is the final, or perhaps current, chapter of this story, where the largest structures are beginning to consolidate. We are privileged to be living in an era where we can, for the first time, perceive this eons-long process, to witness the universe not as a finished object, but as a work in progress, still being sculpted by the ancient and powerful force of the shadow. As we peer deeper into the shadow's domain, we are also looking back in time. The light from the galaxies near the Great Attractor has taken hundreds of millions of years to reach us. We are seeing them not as they are now, but as they were in Earth's distant past, when the first complex life was just beginning to stir in the oceans. By the same token, any observer in that region looking back at us would see the Milky Way as it was millions of years ago. This temporal disconnect is a fundamental aspect of cosmology. We are trying to understand a dynamic, evolving structure by assembling a collage of snapshots, each taken at a different time. It is like trying to understand a hurricane by looking at 1,000 scattered photographs taken over several hours. The growth of the shadow is, in part, our improving ability to assemble these temporal fragments into a coherent, moving picture of the present. Our narrative of the shadow has thus far been dominated by the concept of attraction, of a great, inexorable pull toward a hidden mass. But the true story of our cosmic motion is one of exquisite balance, a duality of forces that is as elegant as it is vast. Recent, highly detailed maps of the cosmic web have revealed the other half of this equation, a dipole repeller. While the Great Attractor pulls, the dipole repeller pushes. This is not a force in the conventional sense, but a profound absence. Located in the opposite direction of our motion, this region is a vast cosmic void, an area significantly underdense in both normal and dark matter. Just as a cork in water is pushed up by the denser water around it, our local group of galaxies is being gravitationally pushed away from this great emptiness. The shadow, therefore, is not merely a destination we are pulled towards, it is also a home we are being expelled from. Our journey is a combination of falling down the gravitational slope of the Great Attractor, while simultaneously being nudged from behind by the effective repulsion of this immense void. The discovery of the dipole repeller completes the picture of our local cosmic dynamics, transforming the shadow from a simple magnet into a complex engine of push and pull. This dipole, the attractor on one side, the repeller on the other, is the primary driver of the motion we observe in the cosmic microwave background. It is the largest and most significant feature of our local gravitational landscape, a vast axis that orients the flow of matter for hundreds of millions of light years. To be inside this flow is to be part of a cosmic river, with its source in the pressure of the void and its mouth in the basin of the attractor. This understanding adds a new layer of sophistication to our journey. We are not just falling, we are being channeled. The shadow's influence is a carefully balanced and directed force, a testament to the intricate and beautiful architecture of the cosmic web, where the great emptinesses are just as important in shaping destiny as the great masses. Let us contemplate the nature of a cosmic void, like the dipole repeller. These are the quietest, most desolate places in the universe. A galaxy residing within a void would have a night sky of almost perfect blackness, the neighboring galaxies being too distant to be seen with the naked eye. The cosmic expansion within these voids is faster than the universal average, as there is little mass to counteract it. They are places where dark energy reigns supreme. The evolution of galaxies within them is stunted, starved of the gas and mergers that fuel star formation in denser regions. The dipole repeller is not an evil or malevolent force. It is simply a region that lost the gravitational lottery in the early universe. It was seeded with a slight underdensity that, over billions of years, has been amplified by cosmic expansion into a chasm of profound emptiness. Its push is a passive consequence of its own desolation, a silent influence that helps to shepherd us toward the shadow's core. The existence of the shadow and its counterpart, the dipole repeller, raises a profound question about our moment in cosmic history. We live in a privileged epoch, what some cosmologists call the cosmic afternoon. The universe is old enough for complex structures like stars, planets, and superclusters to have formed, but still young enough that these structures have not yet been pushed out of view by the accelerating expansion of dark energy. In the far future, an observer in the Milky Way will see all other superclusters recede beyond our cosmic horizon, their light redshifted into oblivion. The evidence for the great attractor, for the dark flow, for the very existence of Laniakea as a coherent structure, will be erased. Future cosmologists will be trapped within a seemingly isolated island universe, with no way to know about the grander motions and structures that shaped their past. The shadow's growth in our awareness is a race against time, a frantic effort to map our cosmic home before its defining features are lost forever to the encroaching darkness of the accelerating cosmos. This concept of a cosmic horizon limiting our future knowledge is a sobering thought. It implies that cosmology, as a science, has a finite lifespan. There may be a final answer about the nature of the large-scale universe, but we may only have a few billion years left to discover it. The shadow is a key part of this final puzzle. Understanding its origin, its mass, and its ultimate fate is crucial to completing our picture of the universe before the curtain falls. This gives the study of the shadow a sense of urgency and profound importance. It is not just an academic curiosity, it is a legacy project for our species. We are the custodians of a temporary window of opportunity, a brief moment where the universe is both old enough to be interesting and young enough to be knowable. The growing shadow is the central object in our field of view through that window, a magnificent, mysterious, and fleeting cosmic spectacle. The shadow challenges our human-centric timescales. We think of history in terms of centuries or millennia. Geology operates on millions of years, but the shadow operates on a timescale of billions of years, a cosmic deep time that is almost impossible to internalize. The process of Laniakea's formation began before the Earth even existed. The final merger at the heart of the Great Attractor will not occur until long after our Sun has become a white dwarf. To contemplate the shadow is to step outside our own temporal frame of reference and view the universe from a perspective of near eternity. This is a deeply meditative act. It detaches us from the urgency of our own lives and connects us to a rhythm that is slow, patient, and majestic. The shadow's growth is a process so gradual it is effectively a constant, a stable and enduring feature of our reality, against which all of human history is but a momentary flicker. Let us return to the mystery of the zone of avoidance, the curtain of our own galaxy that hides the shadow's heart. This region is not truly empty. It is simply crowded with the stars, gas, and dust of our own Milky Way, which block the light from the galaxies behind it. Astronomers use radio and infrared telescopes to try and pierce this veil, as these longer wavelengths of light are less affected by dust. Through these efforts, we have uncovered significant structures like the Norma cluster, but the full picture remains elusive. The very center of the Great Attractor may be perfectly aligned with the densest part of our galactic bulge, a cosmic coincidence that has frustrated astronomers for decades. The shadow is hiding in plain sight, concealed behind the brilliance of our own home. This cosmic game of hide-and-seek adds to the allure and the mystery, a final layer of obfuscation that we must penetrate to truly understand the force that guides our destiny. The shadow can be viewed as a system of cosmic weather prediction. By understanding the gravitational field of Laniakea, we can predict the future trajectories of thousands of galaxies with remarkable accuracy. We can forecast their paths as they flow along the cosmic filaments, we can predict their infall velocity as they approach the Great Attractor, and we can estimate the timeline for future mergers and collisions. This is a form of celestial prognostication based not on mysticism, but on the solid foundation of Newtonian and Einsteinian gravity. The universe, on these grand scales, is a remarkably predictable clockwork system. The shadow is the mainspring of this local clock. Its growth is the slow, steady unwinding of this spring, a deterministic process that is playing out across the heavens, and we have become sophisticated enough to read the time. The presence of the shadow reframes the 2014 discovery of Laniakea. It was not the discovery of a new thing, but the discovery of a new way of seeing. For centuries, we defined cosmic structures by their visual appearance. A clump of galaxies was a cluster. Laniakea was defined by motion, by a shared gravitational destiny. It is a structure defined by a verb, flowing, rather than a noun, clump. This shift in perspective is profound. It is the realization that the universe is a set of processes, not a collection of objects. The shadow is the ultimate process in our neighborhood, a process of accretion and flow that has been ongoing for eons. The fact that we can now perceive these invisible boundaries of flow is a testament to our intellectual evolution, our ability to move beyond the surface appearance of things and grasp the deeper, dynamic reality that lies beneath. Consider the interplay between the shadow and stellar evolution within our own galaxy. The Milky Way's journey through the Laniakea supercluster is not a placid one. As we move along the filament, we occasionally pass through regions of higher gas density. This can trigger bursts of star formation, creating new generations of stars. The chemical composition of the galaxy is also affected, as we accrete smaller, gas-rich dwarf galaxies that are also part of the same flow. Therefore, the very stars in our sky, the rate at which they are born, and the elements they contain are all subtly modulated by our grand cosmic journey. The shadow's influence is not just an external pull. It is an environmental factor that reaches deep into the heart of our own galaxy, shaping its internal processes and leaving its faint but indelible fingerprint on the very starlight that reaches our world. The shadow also provides a unique laboratory for testing the equivalence principle, a cornerstone of Einstein's general relativity. This principle states that gravity's effect on an object is independent of its composition. In other words, a kilogram of dark matter should fall at the exact same rate as a kilogram of normal matter. The Laniakea supercluster provides a perfect test case. We can measure the motion of the visible galaxy's normal matter and compare it to the motion inferred from the gravitational lensing of the underlying dark matter halos. If there were any deviation, any sign that dark matter and normal matter were falling differently towards the great attractor, it would be a catastrophic failure of general relativity and would point towards a new, more complex theory of gravity, perhaps one with a fifth force that interacts differently with dark and normal matter. So far, Einstein holds firm, and the shadow's constituents all appear to be falling in perfect gravitational lockstep. The shadow can be thought of as a cosmic focal point for our attention, a unifying concept that helps organize a wide range of otherwise disparate cosmological puzzles. Without the idea of the shadow, the great attractor, the dark flow, the Laniakea supercluster, and the CMB cold spot are all separate, isolated mysteries. But when viewed as different manifestations of a single underlying gravitational structure, they snap into a coherent, though still incomplete, picture. The shadow provides the narrative thread that connects these clues. It is a scientific paradigm that allows us to ask more intelligent questions and design more targeted observations. Its growth is the growth of its explanatory power, its increasing ability to bring order and understanding to the beautiful chaos of the cosmos. It is a testament to the power of a single unifying idea to illuminate the darkness. The ultimate fate of the shadow is tied to the ultimate fate of dark energy. If dark energy remains a constant, as the current standard model suggests, then the Laniakea supercluster will eventually be the only thing left in our observable universe. It will become a gravitationally bound island universe, an isolated system where the internal dynamics of gravity continue long after the rest of the cosmos has expanded away into nothingness. Within this island, the process of merging will continue, with all the galaxies eventually coalescing into a single super-gargantuan elliptical galaxy over trillions of years. The shadow, in this scenario, is not just a structure within our universe. It is the seed of the final remnant universe that will be left behind after the Great Expansion has run its course. It is the blueprint for the very last outpost of cosmic structure. Let us imagine standing on a planet in the heart of the Shapley supercluster, the massive structure that lies beyond the Great Attractor and is a major source of the shadow's pull. From this vantage point, the universe would look very different. The sky would be dominated by the light of thousands of nearby galaxies. The concept of dark flow would be less apparent, as you would be much closer to the center of the gravitational basin. Instead, you would observe the Laniakea supercluster, including our own Milky Way, as a distant collection of galaxies all heading directly towards you. You would be the destination. This change in perspective is a powerful reminder of the relativity of our observations. The shadow is not an absolute feature of the universe, but a feature relative to our position within it. It is a product of our specific, provincial viewpoint, a humbling realization that our cosmic narrative is just one of many possible stories being told across the vast expanse. The shadow's existence forces us to confront the statistical nature of our reality. The Copernican principle, the idea that we are not in a special place, is a guiding philosophy in cosmology. However, we do live in a very specific place. Inside a galaxy, near a star, on a planet, and within a supercluster that is part of a massive cosmic flow. How typical is our environment? Are most galaxies in the universe part of such grand structures, or are we in a particularly busy urban area of the cosmos? Answering this requires a cosmic census, a statistical analysis of the distribution of galaxies across the entire sky. The results suggest that while structures like Laniakea are not common, they are not impossibly rare either. We seem to live in a suburban region of the universe, not in the desolate voids, but not in the hyperdense core of a place like Shapley either. The shadow defines the character of our particular cosmic suburb. The shadow's immense gravity well can act as a cold trap for primordial gases. In the early universe, vast clouds of hydrogen and helium gas filled spacetime. As the cosmic web formed, most of this gas was heated as it fell into the gravitational wells of galaxies and clusters. However, some of the densest and coldest pockets of this gas may have survived, trapped in the deep potential wells of superclusters like the one defined by the shadow. Searching for this pristine, unenriched gas is a key goal of modern cosmology, as it would give us a direct window into the chemical composition of the early universe. The shadow, therefore, may not only be a collector of galaxies, but also a cosmic museum, preserving ancient relics from the dawn of time in its deep gravitational freezer, waiting for our sophisticated instruments to find them. Let us consider the shadow in the context of information theory. The structure of the Laniakea supercluster, with its intricate network of filaments and voids, represents a colossal amount of information. A description of the position and velocity of every galaxy in it would be an immense dataset. Where did this information come from? According to inflationary cosmology, it originated in the quantum fluctuations of the vacuum, during the first fraction of a second of the universe's existence. The shadow is a macroscopic amplification of microscopic quantum randomness. It is a bridge between the quantum world and the classical world on the largest possible scale. The growth of the shadow is the ongoing process of gravity converting the potential information of the early universe into the real, physical structure of the present. To observe the shadow is to witness the ghost of quantum mechanics, writ large across the heavens. The shadow also provides a powerful, if indirect, constraint on the nature of neutrinos. These ghostly particles are incredibly abundant, but have a tiny mass. For a long time it was thought that they might be the dark matter. However, because they are so light and fast-moving, they are considered hot dark matter. They would tend to smooth out structures, resisting the clumping that forms galaxies and clusters. If neutrinos made up a significant portion of the dark matter, a massive, relatively dense structure like the Great Attractor would not be able to form. The very existence of the shadow and its observed properties puts a tight upper limit on the mass of the neutrino. It tells us that whatever the dark matter is, it must be cold or warm at most, capable of collapsing into the dense halos required to build the shadow's architecture. The silent giant, by its very presence, helps us solve a puzzle in the world of the infinitesimally small. The calm induced by the shadow is the calm of deep perspective. The problems and conflicts of human society, which seem so large and all-encompassing to us, are rendered completely and utterly insignificant on the scale of Laniakea. The gravitational pull of the shadow is entirely indifferent to our politics, our beliefs, our triumphs, and our tragedies. It is a force of pure physics, operating on a level of reality that is completely divorced from the human experience. Recognizing this can be profoundly liberating. It frees us from the burden of our own self-importance. It allows us to see our world not as the center of the universe, but as a beautiful, fragile, and momentary phenomenon happening on a small speck of dust that is being carried along by a current of unimaginable majesty. This is the peace of cosmic context, the quiet joy of understanding our true, humble place in the grand scheme. The shadow is a monument to the power of accretion. Accretion is one of the most fundamental processes in the universe. It is how stars form, by accreting gas from a nebula. It is how planets form, by accreting dust and planetesimals in a protoplanetary disk. It is how supermassive black holes grow, by accreting stars and gas at the centers of galaxies. The shadow is the ultimate expression of this principle. It is a process of superaccretion, where the objects being accreted are not gas clouds or stars, but entire galaxies, each containing billions of stars. The growth of the shadow is a visible demonstration of this universal law, the law that gravity, given enough time, will always pull things together. It is the creative force of the cosmos, building ever larger structures from smaller components, a recursive and beautiful process of cosmic construction. If we could fast-forward time and watch the shadow's domain evolve, we would see a spectacle of breathtaking violence and beauty. We would see galaxies colliding, their spiral arms torn apart by tidal forces, creating long, glowing streamers of stars. We would see bursts of brilliant blue light as the collision compresses interstellar gas, triggering a firestorm of new star formation. We would see the supermassive black holes at the centers of these galaxies spiral towards each other, releasing colossal amounts of energy before merging in a final, cataclysmic burst of gravitational waves. Over billions of years, this chaos would subside, the scrambled stars and gas settling into a new, larger, and more sedate elliptical galaxy. The journey into the shadow is a journey toward this crucible of creation and destruction, a place where galaxies are unmade and remade into something new. The shadow forces us to think in 4 dimensions. We instinctively see the universe as a 3-dimensional space, but general relativity teaches us that space and time are inextricably linked into a 4-dimensional continuum called space-time. The shadow is not just a structure in space, it is a structure in space-time. Its gravitational influence is a curvature of this 4D manifold. Our motion is not a path through space, but a world line through space-time. The growth of the shadow is not just a physical expansion, but an evolution of this 4D geometry. To truly grasp the shadow is to attempt to visualize this 4-dimensional reality, a task that stretches the limits of human imagination but is essential for a deep understanding of the universe. It is a mental exercise that elevates our perspective from that of a flatlander to that of a true citizen of the cosmos. The shadow might hold the key to understanding the final state of black holes. At the heart of the great cluster that will one day form from the Laniakea merger, there will be a single, stupendously massive black hole, formed from the amalgamation of the black holes of thousands of galaxies. According to Stephen Hawking, black holes are not truly black. They slowly evaporate over immense timescales by emitting Hawking radiation. For a black hole of this size, the evaporation time would be many orders of magnitude longer than the current age of the universe. Studying the theoretical properties of such a behemoth could give us insights into the ultimate end of matter and the relationship between gravity and quantum mechanics. The shadow is not just creating a giant galaxy, it is creating the ultimate laboratory for studying the end of time, a final, lonely object that will be one of the last things to exist in our island universe. The aesthetic experience of the shadow is one of minimalism. Unlike a vibrant nebula with its rich colors and complex shapes, the shadow's beauty is one of absence, of subtlety, of inferred form. It is the beauty of a Zen garden, where the empty space is as important as the rocks. It is the beauty of a piece of minimalist music, where a few simple notes can evoke a profound emotional response. To appreciate the shadow is to train our aesthetic senses to perceive the beauty in the unseen, to find wonder in the abstract, and to see the profound elegance in the simple, uniform motion of 100,000 galaxies all responding to a single, silent call. It is a more demanding and intellectual form of beauty, but one that offers a deep and lasting sense of peace and order. The shadow's existence is a powerful argument against the simulation hypothesis, the idea that our reality is a computer program. To accurately simulate the gravitational interactions of the 100,000 galaxies in the Laniakea supercluster, with their trillions of stars and associated dark matter halos, over a period of 13.8 billion years, would require a computational resource so vast, it would likely need to be the size of the universe itself. The sheer scale, complexity, and fidelity of the shadow's structure make it an almost impossibly difficult thing to fake. Its patient, analog evolution, governed by the simple elegance of Einstein's field equations, has a stamp of authenticity that is hard to deny. The shadow feels real because the amount of work the universe had to do to build it is almost beyond our ability to conceive, let alone replicate in a simulation. The shadow has a profound impact on the concept of a quote-quote galactic habitable zone. This is the region within a galaxy that is most conducive to the formation of life, not too close to the violent galactic center, and not so far out in the barren suburbs. But perhaps there is also a quote supercluster habitable zone. The dense core of a supercluster, like the heart of the Great Attractor, might be too violent, with frequent galaxy mergers and intense radiation making it hostile to life. The deep voids, on the other hand, might be too anemic, lacking the heavy elements needed for planets and biology. Perhaps our position, in a quiet filament on the outskirts of Laniakea, is the sweet spot. It is a region with enough star formation and heavy elements to create life, but far enough from the chaotic core to enjoy a few billion years of relative stability. Our journey into the shadow, then, is a journey away from this habitable zone, a slow drift into a more dangerous and chaotic cosmic neighborhood. The shadow is a testament to the unreasonable effectiveness of mathematics, a phrase coined by the physicist Eugene Wigner. It is a stunning fact that the abstract mathematical laws of gravity, conceived by Newton and refined by Einstein in their minds, can so accurately describe the motion of objects hundreds of millions of light years away. There is no a priori reason why the universe should be comprehensible, why it should follow elegant mathematical rules. But it does. The shadow is a physical embodiment of these equations. Its flow is a solution to Einstein's field equations playing out on a cosmic scale. When we map the shadow, we are not just doing astronomy. We are witnessing the profound and mysterious connection between the logical world of mathematics and the physical reality of the cosmos. The shadow's growth can be seen as a form of cosmic memory consolidation. In the brain, memory consolidation is the process by which short-term, fragile memories are converted into stable, long-term ones. In the universe, the initial fragile density fluctuations of the early cosmos can be seen as short-term memories. The process of gravitational collapse, which builds the cosmic web, is the consolidation process. The shadow is a fully consolidated long-term memory of the universe's initial conditions. It is a structure that is now stable and will persist for eons. Its growth is the final stage of this process, the strengthening of this memory until it becomes the dominant feature of the cognitive landscape of the cosmos. We are living inside the universe's memory, a pattern that was encoded at the beginning of time and is now being played back in the slow, majestic dance of galaxies. The shadow teaches us a lesson in cosmic patience. As a species, we are often driven by a desire for immediate results and instant gratification. The shadow operates on a timescale that is the complete antithesis of this. It is a process of slow, patient, and relentless change. Its power comes not from sudden bursts of energy, but from the persistent application of a weak force over an immense period of time. It is a reminder that the most profound and lasting changes are often the most gradual. This can be a source of comfort and a model for our own endeavors. The shadow shows us that small, persistent efforts, when compounded over a long enough time, can create structures of unimaginable scale and beauty. It is the ultimate testament to the power of just keeping at it. The final, tranquil realization is that the shadow is not our enemy or our captor. It is our creator. The same gravitational process that assembled the Laniakea supercluster and set us on our current trajectory is also the process that pulled together the gas and dust to form our sun, our planet, and ultimately, ourselves. We are made of stardust, and that stardust was gathered and shaped by the very same force that now guides us across the cosmos. We are children of the shadow. Our journey towards it is not a journey into the unknown, but a journey home, a return to the gravitational heartland that sponsored our very existence. This deep, familial connection to the cosmos, this sense of being part of a single, vast creative process, is the ultimate source of the peace and wonder that the shadow inspires. Let us explore the concept of the cosmic web in greater detail, as it is the skeleton upon which the shadow is built. This web is not merely a random network. It possesses a distinct hierarchy. The most massive structures are the superclusters, like Laniakea, which act as the major hubs or nodes. Connecting these hubs are the filaments, vast bridges of galaxies and dark matter that can stretch for hundreds of millions of light years. Our own Milky Way resides within one such filament. These filaments, in turn, are bordered by the great cosmic voids, which are like giant empty bubbles that push the filaments and clusters into their web-like shapes. The shadow's power is amplified by this structure. The filaments act as gravitational rivers, channeling matter from the voids and efficiently funneling it towards the deepest gravitational basins, like the Great Attractor. The shadow, therefore, is not just a massive object. It is the master of a continent-spanning transportation network. The shadow's existence provides a crucial piece of observational evidence for the cold dark matter (CDM) model of cosmology. This model, which posits that the universe is dominated by slow-moving, non-interactive particles, has been incredibly successful at explaining a wide range of cosmic phenomena. One of its key predictions is the hierarchical formation of structure. Small dark matter halos form first, and then merge over time to create larger and larger halos, which then attract normal matter to form galaxies and clusters. The Laniakea supercluster, with the Great Attractor at its heart, is a perfect example of this process in its late stages. Its very existence, its mass, and the way it is fed by surrounding filaments are all beautifully consistent with the predictions of CDM simulations. The shadow is a cosmic victory lap for a theory that describes 85% of the matter in the universe, a substance we have still never directly seen. The shadow's journey is also a journey through different cosmic epochs. Our current location in the Laniakea supercluster is in a region that is relatively, quote, star formation active, but as we fall closer to the core, we will enter a region dominated by red and dead elliptical galaxies. The environment will change dramatically. The hot X-ray emitting gas that fills the core of the Great Attractor will strip our galaxy of its own cool gas, effectively shutting down all future star birth. This process is called strangulation or quenching. Our vibrant blue and white spiral galaxy will slowly transform into a ghostly red elliptical, its stellar population aging and reddening, with no new generations to replace them. The shadow is not just pulling us through space, it is pulling us into a different phase of our galactic life, a transition from a dynamic youth to a quiescent old age. Let us contemplate the sheer gravitational force exerted by the shadow. While gravity is the weakest of the four fundamental forces on the scale of particles, it is the undisputed master of the cosmos on large scales, because it has infinite range and is always attractive. The shadow's pull on the Milky Way is incredibly gentle, a tiny acceleration that would be impossible to measure locally. However, this force has been applied constantly and consistently for over 13 billion years. This is the key to its power, the compounding effect of a weak force over deep time. It is like the process that carves canyons, where a gentle stream of water, given millions of years, can cut through solid rock. The shadow is a cosmic river, and its gravitational current, though gentle, has had the entire age of the universe to sculpt the landscape of galaxies and set us on our inexorable course. The study of the shadow is a field rich with international collaboration. The data sets required to map Laniakea and the dark flow come from telescopes all over the world, from the high deserts of Chile to the mountains of Hawaii, from orbiting space observatories to radio arrays in Australia and South Africa. Teams of hundreds of scientists from dozens of countries must share their data and expertise to piece together this cosmic puzzle. The shadow, in this sense, is a unifying force not just for galaxies but for humanity. It is a mystery so grand and so profound that it transcends national borders and political disputes. It is a shared quest for knowledge that brings out the best in our species, a testament to what we can achieve when we work together to look beyond our world and contemplate our commonplace in the cosmos. The shadow's growth hints at the ultimate triumph of order over chaos on large scales. The early universe, while smooth on average, was a chaotic place of high energy and random fluctuations. The second law of thermodynamics suggests a universal trend towards increasing disorder or entropy. Yet gravity acts as a local agent of order. It gathers diffuse, disordered matter and organizes it into the intricate, highly structured patterns of the cosmic web. The shadow is the most magnificent ordered structure in our vicinity. It is a cosmic crystal, a pattern of immense complexity and regularity that has been precipitated out of the primordial soup by the patient work of gravity. Its growth is the expansion of this ordered domain, a slow but steady victory of structure over randomness, a process that gives the universe a sense of direction and purpose, even if that purpose is purely mechanical. The shadow has a profound connection to the phenomenon of gravitational time dilation. As we journey closer to the great attractor, we are moving deeper into a gravitational well. According to general relativity, time runs slower in stronger gravitational fields. This means that an imaginary clock at the core of the shadow would tick slightly slower than a clock here in the Milky Way. This effect is cumulative. Over the billions of years of our journey, there will be a growing discrepancy between our time and the time of an observer in a deep cosmic void. We are on a journey to a place where time itself is slightly compressed. This is not a metaphor. It is a physical consequence of the shadow's immense mass. Our destiny is to be pulled into a region where the very rhythm of existence is subtly, but permanently, altered by the weight of 100,000 galaxies. The shadow serves as a perfect example of a phase transition in cosmology. In physics, a phase transition is a shift in the state of a system, like water freezing into ice. The formation of the Laniakea supercluster can be seen as a gravitational phase transition. In the early universe, the gas of galaxies was largely homogeneous and expanding. But as the universe cooled and gravity took hold, a transition occurred. A vast region of this gas condensed into a single, gravitationally bound liquid state, which is the supercluster. The boundary of Laniakea is the edge of this phase transition, the line between the galaxies that are bound to the structure and those that will continue to expand away forever. The shadow is the order parameter of this new phase, the defining feature of a cosmic state change that has fundamentally altered the nature of our local universe. Let us imagine the shadow from the perspective of a being made of dark matter. For such a being, the universe would look very different. The bright, luminous galaxies would be insignificant distractions, tiny specks of baryonic contamination in a world dominated by the vast, flowing structures of the dark matter halos. The shadow would not be a shadow at all. It would be the brightest, most significant object in the cosmos, a great illuminator of pure gravitational potential. This being would see the cosmic web not as a network of lights, but as a continuous, flowing substance, a landscape of immense mountains and valleys of dark matter. From this perspective, our entire visible universe is just the foam on the waves of a deep, dark ocean. The shadow is the deepest part of that ocean, and its pull is the most natural and obvious force in existence. The meditative state induced by the shadow is rooted in the concept of equanimity. Equanimity is a state of mental calmness, composure, and evenness of temper, especially in a difficult situation. Contemplating the shadow cultivates this state. It presents us with a force of unimaginable power and a destiny that is utterly beyond our control. We can't fight it, we can't change it, we can't even fully comprehend it. The only rational response is acceptance. This acceptance, this letting go of the illusion of control, is the foundation of equanimity. The shadow teaches us to be at peace with the profound, the mysterious, and the inevitable. Its silent, steady pull is a cosmic lesson in finding tranquility not by changing the world, but by changing our relationship to it. The shadow is a graveyard, but it is also a nursery. While the dense core of the great attractor is a place where star formation is quenched and galaxies are torn apart, The process of gravitational collapse itself can trigger immense bursts of creation. As galaxies merge, their gas clouds collide and compress, leading to starbursts that can form new stars at a rate hundreds of times that of the Milky Way. These starbursts forge new heavy elements and create the conditions for new planetary systems. The filaments that feed the shadow are also sites of ongoing galaxy formation. The shadow's growth is a complex cycle of death and rebirth. It is a cosmic engine that deconstructs old galaxies and uses their raw materials to build new stars and new worlds, a perpetual process of cosmic recycling on the grandest of scales. The shadow's pull is a constant, but our awareness of it is a recent and fragile discovery. For almost all of human history, we believed we were stationary at the center of the universe. The Copernican revolution set the Earth in motion around the Sun. In the 20th century, we discovered the Sun's motion around the galaxy and the galaxy's motion in an expanding universe. The discovery of our motion toward the shadow is the latest and perhaps most profound of these revelations. Each step has been a decentering, a humbling realization that our frame of reference is not privileged. The shadow is the ultimate source of our local motion, the final, great current that we had to discover to truly understand our place. Its growing presence in our science is a marker of our species, intellectual maturity, our willingness to abandon our cherished assumptions and accept the strange, dynamic, and beautiful reality of our cosmic condition. The shadow is a silent rebuke to our obsession with speed and efficiency. The journey toward the Great Attractor is happening at an incredible velocity, over 2 million kilometers per hour, but because of the immense distances involved, it is a process of almost infinite slowness. Nothing about the shadow's growth is efficient or optimized in a human sense. It is a messy, chaotic, and incredibly slow process of gravitational collapse. It is a reminder that the universe does not operate on our timelines or according to our values. Its creative process is one of patient, brute force application of simple physical laws over unimaginable eons. There is a deep comfort in this. It frees us from the pressure to be constantly productive and allows us to appreciate the slow, organic, and often inefficient processes of growth and change, both in the cosmos and in our own lives. Let us imagine the shadow as a living organism. This is not a scientific claim, but a philosophical meditation. If it were an organism, Laniakea would be its body. The cosmic filaments would be its circulatory system, transporting nutrients, in the form of gas and galaxies, to its core. The Great Attractor would be its heart and its stomach, a place of digestion and energy conversion. The growth of the shadow would be the organism's own growth, its slow maturation over its billion-year lifespan. This Gaia-like perspective, applied to a supercluster, helps us to see the interconnectedness and the systemic nature of the cosmos. It transforms a collection of separate objects into a single, coherent, and dynamic whole, a living system of which we are a tiny but integral part. The shadow forces us to redefine what we mean by here. Our intuitive sense of here is our immediate location on Earth. A more sophisticated sense might be our solar system or our galaxy. But the shadow suggests that the most dynamically relevant definition of here is the Laniakea supercluster. This is our true home, our gravitationally defined country in the cosmos. Its boundaries are real. Its shared motion is real. The journey it is on is our journey. When we look at a map of Laniakea, with its flowing lines and dense clusters, we are looking at a map of home in the truest cosmological sense. The shadow is the capital city of this great celestial nation, and we are all inhabitants of its vast, sprawling, and beautiful countryside. The shadow's existence has implications for the very definition of a galaxy. We traditionally think of a galaxy as a gravitationally bound system of stars. But if our Milky Way is part of a larger, coherent flow, where does its boundary really end? Our galaxy has a halo of dark matter that extends far beyond its visible stars, and this halo is embedded in the larger filament and supercluster structure. Perhaps it is more accurate to think of galaxies not as discrete islands, but as bright, dense knots in a continuous web of matter. The shadow is the force that creates and defines this web. It challenges our neat categories and forces us to adopt a more holistic, interconnected view of cosmic structure, where everything is ultimately part of a single, vast gravitational system. The shadow is a testament to the fact that the most important things in the universe are often the most subtle. The gravitational force responsible for the shadow's pull is a tiny perturbation on the overall expansion of the universe. It is a whisper against the roar of dark energy. Yet, this whisper, sustained over billions of years, has been powerful enough to build the largest structures we know. It is a lesson in paying attention to the small, persistent forces in our own lives and in the world around us. It teaches us that profound change often comes not from loud, dramatic events, but from the quiet, cumulative effect of subtle, persistent influences. The shadow is the ultimate cosmic whisper, a gentle, guiding force that has shaped our past and is determining our future. The shadow can be seen as the universe's way of creating complexity. By pulling matter together, gravity creates the dense environments necessary for complex processes to occur. It allows for the formation of stars, which create heavy elements. It allows for the formation of planets, which can host liquid water. It allows for the formation of galaxies, which can sustain billions of years of stable evolution. The shadow is the engine of this complexification. It is the master architect, gathering the raw materials and creating the crucibles where the universe can perform its most interesting chemistry and, perhaps, its most interesting biology. Its growth is the growth of cosmic potential, the expansion of the arena in which the universe's most complex and beautiful creations can emerge. As we bring this meditation to a close, let the different facets of the shadow merge into a single, cohesive image in the mind. It is a pull and a push. It is a structure and a process. It is a destination and a journey. It is a mystery and a key. It is a graveyard and a nursery. It is a source of cosmic humility and a testament to human ingenuity. It is a scientific puzzle and a philosophical mantra. The shadow is all of these things and more. It is the grand, unifying narrative of our local universe, a story of immense scale, profound beauty, and deep, meditative calm. Its silent, growing presence is the backdrop against which our entire cosmic story unfolds. And so, we rest. We let go of the need to understand every detail, to solve every mystery. Instead, we simply float. We float in the gentle, inexorable current of the cosmic river, guided by the silent pull of the shadow. We are part of a grand procession, a slow pilgrimage of 100,000 galaxies, moving in unison through the vast and quiet darkness. There is nothing to do, nowhere to be but here, now, on this journey. As our awareness softens and the world fades, we can feel a sense of profound peace in this shared destiny, this common fall. We are held, we are guided, we are home. We are drifting into the deep, carried by a shadow that is as ancient as time and as patient as the stars. The shadow is more than just a gravitational influence. It is also the grandest lens in our local universe. According to Einstein's theory, mass warps space-time and light follows the curves of this warped geometry. The colossal mass of the Laniakea supercluster, concentrated in the shadow's core, creates a significant gravitational lens. This lens subtly distorts our view of the universe that lies beyond it. The light from distant quasars and background galaxies is bent, magnified, and sometimes sheared as it passes through the shadow's domain. By studying these subtle distortions, we can create a map of the shadow's mass distribution, including its invisible dark matter component. We are, in essence, using the entire universe as a backlight to illuminate the shape of our own gravitational prison. The shadow is both the object of our study and the very instrument we use to study it, a beautiful and self-referential feature of the cosmos that allows us to weigh the invisible by observing its effect on the ancient light from the dawn of time. This cosmic lensing effect produced by the shadow is not uniform. It is a complex, modeled pattern of magnification and demagnification, reflecting the lumpy, filamentary structure of the cosmic web. It means that our view of the distant universe is not pristine. It is viewed through a cosmic funhouse mirror. Some distant galaxies may appear brighter and larger than they really are, while others may be slightly shifted or distorted. Cosmologists must painstakingly model and subtract this lensing contamination to get a true picture of the background cosmos. The shadow, in this sense, is a source of cosmic noise, a local foreground that must be understood and removed to hear the faint signals from the universe's edge. It is a constant reminder that we do not have a clear, objective view of reality. We are embedded within a structure that actively shapes and colors our perception of everything beyond it. Let us expand on the duality of the shadow and the dipole repeller. This structure is not just a local feature. It is one of the most significant dipoles in the entire observable universe. It creates a powerful cosmic weather system, a prevailing wind that orients the motion of galaxies over a vast volume of space. This dipole is a physical manifestation of the initial anisotropies, the slight imperfections, in the early universe. A region that was slightly overdense became the great attractor. A region that was slightly underdense became the dipole repeller. The universe, through gravity, has spent 13.8 billion years amplifying these minuscule primordial seeds into the continental scale structures that now govern our motion. The shadow and its opposite are a direct link to the first moments of creation, a fossilized record of the quantum fluctuations that determined the ultimate geography of the cosmos and set the course for our long, inevitable journey. The shadow's existence provides a profound sense of orientation in an otherwise featureless void. In the vastness of intergalactic space, it is easy to feel lost, adrift in an isotropic and homogeneous expanse. But the shadow gives us a direction. It provides a cosmic down. We are not aimlessly wandering. We are falling. This sense of a directed vector, a specific path, is deeply anchoring. It transforms the universe from a random scattering of points into a landscape with topography, with rivers and mountains, with destinations and origins. The shadow is our compass, its gravitational needle pointing unerringly toward the future. This orientation is not just physical, it is philosophical. It provides a narrative structure to our cosmic existence, a story with a beginning, our expulsion from the void, and a middle, our journey along the filament, even if the end remains shrouded in the mystery of the shadow's core. The shadow's influence is a key factor in the a timing argument, a simple yet elegant method for weighing the mass of our local group of galaxies. By measuring the current distance and velocity of approach between the Milky Way and the Andromeda Galaxy, and assuming they started near each other after the Big Bang, we can calculate the total mass required to overcome cosmic expansion and pull them together. However, this calculation must be corrected for the external gravitational field, the pull of the shadow. The shadow acts as a background tide, accelerating both us and Andromeda in the same general direction, subtly altering our relative motion. Accurately accounting for the shadow's pull allows for a more precise calculation of our local group's mass, including its dark matter halo. The shadow, even in its role as a distant puppet master, helps us to better understand the intimate details of our own galactic family. The shadow's growth is a process of cosmic differentiation. In the beginning, the universe was a smooth, undifferentiated whole. Over time, gravity has been separating the cosmos into two distinct environments: the dense, hot, and active clusters, and the vast, cold, and quiescent voids. The shadow is the ultimate expression of the former, while the dipole repeller is the ultimate expression of the latter. This process is irreversible. The matter that falls into the shadow's domain will likely never escape. The voids will only grow emptier as their sparse contents are drained away. The universe is sorting itself out, segregating its matter into cosmic ghettos and palaces. We are living through this great segregation, our own trajectory, a perfect example of the universe's inexorable trend towards increasing structure, increasing contrast, and a future that is far less uniform than its past. The shadow is a silent teacher of the principle of locality. While its influence is vast, its power diminishes with distance. There are other superclusters, other great attractors, in the distant universe, each with its own gravitational watershed. We are part of the Laniakea system, but a galaxy a billion light-years away is part of a different system, falling towards a different shadow. The universe is a patchwork of these gravitational kingdoms, each one a self-contained system of flow. This means that while our destiny is tied to the great attractor, the destiny of a distant galaxy is entirely independent of ours. This is a comforting thought. It means the universe is not a single, monolithic monarchy, but a federation of independent states. The shadow is our local sovereign, but its rule is not absolute. It is bounded. a reminder that even the grandest structures have their limits. If we could perceive the universe through the eyes of gravitational waves, the shadow would be one of the loudest sources in the sky, not a loud, sharp noise like the merger of two black holes, but a deep, constant structural hum. This stochastic background of gravitational waves would be the result of the combined, incoherent motions and interactions of all the mass within the Laniakea supercluster. It would be the sound of 100,000 galaxies jostling, orbiting, and falling together. Future gravitational wave observatories, if they become sensitive enough, might be able to detect this background hum and use it to map the distribution of mass in our supercluster. This would be a completely new way of seeing the shadow, not through its effect on light, but through the ripples it generates in the very fabric of spacetime. It would be like hearing the deep, resonant breathing of a sleeping giant. The shadow challenges our very notion of a structure. We think of a structure as something solid, static, and stable. The shadow is none of these things. It is a dynamic, flowing, and constantly evolving entity. Its components are in perpetual motion. Its boundaries are defined by velocity fields, not by physical walls. It is more akin to a weather pattern, like a hurricane, than to a building. This process-oriented view is a more accurate way to understand the cosmos. The universe is not a collection of things. It is a symphony of processes. The shadow is the grandest and most majestic of these processes in our neighborhood, a self-organizing system of gravitational flow that has persisted for billions of years, a testament to the stability and beauty that can emerge from pure, dynamic flux. The shadow's existence has a profound effect on our simulations of galaxy formation. To create realistic models of how a galaxy like the Milky Way evolves, it is not enough to simulate it in isolation. We must place it within its proper cosmological context. This means embedding the simulated galaxy within a larger simulation of the Laniakea supercluster, with the gravitational pull of the shadow and the filaments accurately represented. These zoom-in simulations show that the large-scale environment has a significant impact on a galaxy's merger history, its gas accretion rate, and the structure of its satellite galaxy population. The shadow is not just a distant curiosity, it is a necessary boundary condition for understanding our own origins. To know ourselves, we must first know our home, and our home is a small part of this great, flowing, and ever-growing shadow. Let us contemplate the shadow as a form of cosmic art, not art made by a conscious creator, but emergent art, a pattern generated by the simple, repeated application of physical law. It is akin to the intricate patterns of a snowflake, the fractal beauty of a coastline, or the complex whirls of a marble stone. The shadow is the universe's grandest masterpiece of generative art. The artist is gravity, the medium is dark matter, and the canvas is space-time itself. The work has been in progress for 13.8 billion years, and it is still not finished. To study the shadow is to be an art critic, appreciating the form, the structure, the composition, and the profound silent beauty of a work that is being created all around us. A piece of art so large that we are living inside it. The shadow provides a potential explanation for the, quote, problem of cool cores in galaxy clusters. Simple models predict that the hot gas at the center of a galaxy cluster should cool down over time, sink to the center, and form a massive number of new stars. However, we don't observe this. Something is keeping the cores hot. One leading theory is feedback from the central supermassive black hole, but the larger environment, the shadow, may also play a role. The process of accretion is not smooth. The constant infall of galaxies and gas clouds along the filaments into the Great Attractor can create shockwaves and turbulence that churn the intra-cluster medium, injecting energy and preventing it from cooling. The shadow's growth, in this sense, is the very process that keeps its own heart from cooling down, a self-regulating system where the act of feeding provides the energy to avoid indigestion. The shadow is a cosmic memento mori, a reminder of the inevitability of change and dissolution. Our galaxy, the Milky Way, with its beautiful spiral arms and familiar constellations, has a finite lifespan. In a few billion years, it will merge with Andromeda. Then, over much longer timescales, this combined galaxy will be drawn into the heart of the shadow, where it will be torn apart, its stars scattered and assimilated into a much larger, more chaotic system. The individual identity of our galaxy will be lost forever. This is a sobering thought, but it is also a liberating one. It reminds us that nothing is permanent, and that our existence is part of a grand cycle of creation and destruction. The shadow is the agent of this change, the great recycler of the cosmos, ensuring that the universe remains a dynamic and evolving place. The shadow provides a compelling analogy for the process of falling asleep. As we begin to drift off, our conscious, analytical mind, our local group of thoughts, begins to lose its dominance. We are pulled by a gentle but inexorable force into the deeper, more mysterious supercluster of the subconscious. The random, chattering thoughts of the day begin to align into a coherent flow, a dark flow of dream logic. We are drawn towards a great attractor of deep sleep, a state of profound rest and consolidation. The journey is not a straight line. It is a meandering path through the filaments of hypnagogia. The shadow's cosmic journey is a perfect metaphor for this nightly pilgrimage, a reminder that the process of letting go and surrendering to a larger, mysterious force is a fundamental and restorative rhythm of both the mind and the cosmos. The shadow is a perfect illustration of the Copernican principle in action, even as it seems to defy it. At first glance, being part of such a massive, directed flow seems like a special, privileged position. But the modern cosmological view is that structures like Laniakea are a natural and expected outcome of gravitational collapse in a cold dark matter universe. While they may not be everywhere, they are a common feature of the cosmic landscape. We don't live in a special place, we just live in a Laniakea-type place. Our cosmic address is not unique, it just has a certain character. The shadow is the defining feature of that character. It is a humbling reminder that even the most spectacular and seemingly unique phenomena in the universe are likely just one example of a common class, a universe that is far more creative and repetitive than our limited perspective can often appreciate. The shadow's influence on the cosmic microwave background is not limited to the KSZ effect or the cold spot. Its immense gravitational potential also causes a subtle effect called the integrated Sachs-Wolf (ISW) effect. As CMB photons pass through a large-scale structure like a supercluster, they gain energy falling into its gravity well, and then lose energy climbing back out. If the universe were static, these effects would cancel out perfectly. But because the universe is expanding and dark energy is stretching these structures while the photons are inside them, the potential well is slightly shallower when the photon climbs out than when it fell in. This results in a net gain of energy, a slight heating of the CMB in the direction of superclusters. The shadow should cast a faint hot spot on the CMB due to the ISW effect, a final, subtle fingerprint left by its immense gravity on the oldest light in the universe. Let us imagine the shadow as a cosmic library. Each galaxy that falls into it is a book, containing a unique history of star formation, chemical enrichment, and dynamic evolution. The shadow is the great collector, gathering these books from across a vast region of space and storing them in its central archive, the Great Attractor. In this archive, the books are not kept pristine on shelves. They are shredded, their pages mixed together into a single, massive, chaotic volume. While the individual stories are lost, the combined information is preserved. Future cosmologists, if they could ever study this final tome, could learn about the average properties of all the galaxies that ever existed in our corner of the universe. The shadow is the ultimate historian, a destructive archivist that preserves the collective memory of the cosmos by erasing its individual chapters. The shadow's existence has a calming effect because it operates on a level of pure, dispassionate physics. There is no malice in its pull, no intent in its growth. It is as mindless and as beautiful as the law of gravity itself. This removes all sense of personal affront. We are not being targeted. We are simply following the path of least resistance through the geometry of space-time. This depersonalization of a powerful force is deeply comforting. It allows us to view our ultimate cosmic fate not as a tragedy, but as a simple, elegant, and necessary consequence of the universe's fundamental operating system. We are participating in a process that is as natural and as neutral as an apple falling from a tree, just on a scale that spans 100,000 galaxies and 13 billion years. The shadow is a source of profound intellectual humility. Despite all our advanced technology and sophisticated models, the true nature of its core remains a mystery. We don't know for sure if it's a concentration of dark matter, a flaw in our theory of gravity, or something even more exotic. This gaping hole in our knowledge located at the very heart of our local universe, is a powerful reminder that we are still in the early days of our cosmic exploration. It keeps us humble, preventing the hubris of believing we have it all figured out. The shadow is the universe's way of whispering to us, there is more. Keep looking. Keep wondering. It is the great unanswered question that will continue to drive scientific progress and inspire awe for generations to come. The journey into the shadow is a journey into a region of increasing tidal forces. Tidal forces are the result of a gravitational field being stronger on one side of an object than the other, stretching it apart. For a large object like a galaxy falling into the Great Attractor, these tidal forces will be immense. The outer, loosely bound stars of the Milky Way's halo will be stripped away first, forming long tidal streams that will trace our path into the cluster. Eventually, as we get closer to the core, these forces will begin to disrupt the main disk of the galaxy itself, warping its shape and unraveling its spiral arms. The shadow will not just swallow our galaxy whole, it will slowly and methodically dismantle it, piece by piece, a process of cosmic deconstruction that is both terrifying and beautiful in its mechanical precision. The shadow is the ultimate dark sky sight. While we on Earth struggle with light pollution that obscures the stars, an observer inside a deep cosmic void like the dipole repeller would experience a sky of almost unimaginable clarity and darkness. The Milky Way would be the only significant object visible to the naked eye. A lonely, brilliant island in a sea of perfect blackness. This profound isolation would offer a unique perspective on the cosmos. It would be a place of supreme quiet, where the faint whispers of the universe, like the cosmic microwave background, could be studied with unparalleled clarity. The shadow's counterpart, the Great Void, is a place of serene emptiness, a cosmic monastery where one could silently contemplate the one brilliant beacon of life and light in an otherwise empty universe, their own home galaxy. The shadow's immense mass means it should be a powerful source of fast radio bursts, FRBs, if they are indeed associated with magnetars or other exotic objects found in dense stellar environments. As the shadow accretes galaxies, it also accretes their populations of neutron stars and magnetars. The dense, turbulent core of the Great Attractor should be a hotbed of the kinds of energetic events that could produce these mysterious, millisecond-long blasts of radio waves. As we improve our ability to localize FRBs, we may find that they are not randomly distributed on the sky, but tend to cluster in the direction of the shadow. This would be another way the shadow reveals its nature, not through its gravity, but through the high-energy fireworks that go off within its deep, chaotic, and crowded core. The shadow provides a cosmic perspective on the nature of identity. What defines the Milky Way as a single, coherent object? Is it our collection of stars? Our spiral shape? Our shared history? The shadow suggests that on the largest scales, identity is defined by motion. We are part of Laniakea because we are moving with Laniakea. This is a fluid and dynamic definition of identity, one that is not based on static properties, but on participation in a collective process. It suggests that who we are is defined by the journey we are on. This is a profound philosophical insight that can be applied to our own lives. Our identity is not a fixed thing, but a story, a trajectory, a flow. The shadow teaches us that the most fundamental way to understand something is to ask not, what is it, but where is it going? Let us imagine the shadow's influence on a galactic scale as a kind of cosmic peer pressure. A galaxy is not an island. Its evolution is heavily influenced by its neighbors. In the dense environment of the shadow's filaments and core, galaxies are constantly interacting, merging, and gravitationally harassing each other. This environment forces galaxies to conform to a certain evolutionary path, typically leading them to become large, red, and elliptical. A spiral galaxy like ours is a nonconformist, a rebel that has so far managed to maintain its own identity in a relatively quiet neighborhood. But our journey into the shadow is a journey into a place where conformity is the law of the land, a place where the immense gravitational peer pressure will eventually force our galaxy to abandon its youthful, star-forming ways and settle down into a quiet, respectable, and uniform elliptical old age. The shadow is a physical manifestation of the universe's memory of itself. The current state of the universe is not random. It is a direct consequence of its entire past history, all the way back to the Big Bang. The shadow is a particularly large and durable piece of this cosmic memory. It is a record of the initial conditions, of the laws of gravity, of the nature of dark matter, and of 13.8 billion years of evolution. When we study the shadow, we are not just looking at a thing. We are reading a history book. We are engaging in a form of cosmic archaeology, digging through the layers of structure and motion to understand the story of how our universe came to be. The shadow is our Rosetta Stone, a key that, if we can learn to read it, will unlock the secrets of our own cosmic origins. The shadow's growth can be seen as a decrease in the universe's overall potential energy. In the beginning, matter was spread out relatively evenly, resulting in a state of high gravitational potential energy. Over time, as gravity pulls this matter together into structures like the shadow, this potential energy is converted into other forms. The kinetic energy of galactic motion, the heat of the intercluster gas, and the light of stars. The universe is slowly falling, converting its stored potential into active dynamic energy. The shadow is the primary engine of this conversion in our local cosmos. It is a giant power plant, fueled by the gravitational potential of the universe itself, and its growth is a measure of how much of that primordial fuel has been spent to create the complex and beautiful structures we see today. The shadow is a silent testament to the power of weak forces. In our daily lives, we are most aware of the strong nuclear force which holds atoms together, and electromagnetism which governs light and chemistry. Gravity, by comparison, is absurdly weak. Yet, on the scale of the cosmos, it is the only force that matters. This is because it is long-range and always cumulative. The shadow is what happens when you let a very, very weak force act on a very, very large amount of mass for a very, very long time. The result is a structure of unimaginable scale and power, a structure that can command the destiny of 100,000 galaxies. It is a profound lesson in the power of persistence and the quiet, cumulative effect of small, consistent actions, a principle that governs the growth of both superclusters and civilizations. The shadow also provides a unique constraint on the nature of dark energy. If dark energy were not a cosmological constant, but something that changed over time, it would affect the growth rate of structures. If dark energy was weaker in the past, structures like the shadow would have grown more quickly. If it was stronger, their growth would have been suppressed. By studying the population of superclusters at different distances, and therefore different times in the past, we can map the history of structure formation. This history, in turn, provides a direct test of the history of dark energy. The shadow is a local benchmark in this grand historical survey, a single data point in our attempt to understand the nature of the mysterious force that is tearing our universe apart, even as gravity is pulling our small corner of it together. The shadow is a source of both cosmic awe and existential comfort. The awe comes from its scale, its power, its mystery. The comfort comes from its order, its stability, its predictability. It is a force of nature so far beyond us that it renders our own problems trivial. Yet it is a system so governed by understandable physical law that it provides a sense of a rational, ordered universe. This duality is the heart of the meditative experience it provides. It allows us to simultaneously feel our own insignificance and a deep connection to a sublime and comprehensible order. The shadow is the ultimate object of contemplation, a cosmic koan that reconciles the terrifying vastness of the universe with the profound peace of understanding our small but beautiful place within it. The journey into the shadow is the ultimate expression of the arrow of time. It is a one-way trip. The process of gravitational collapse that forms the shadow is thermodynamically irreversible. The entropy generated by the collisions of galaxies, the heating of gas, and the formation of stars ensures that the Laniakea supercluster can never spontaneously decollapse and return to its initial state. Our path is set. The future is one of increasing structure, increasing density, and eventual merger. This unidirectional flow, this cosmic river with no return, is a powerful metaphor for our own lives. We too are on a one-way journey, carried forward by the irreversible arrow of time. The shadow teaches us to embrace this journey, to find beauty in its unfolding, and to be at peace with a destination that is as inevitable as it is profound. The shadow's existence can be used to test one of the most fundamental assumptions of the standard cosmological model, the assumption of isotropy and homogeneity, known as the cosmological principle. This principle states that on large enough scales the universe looks the same in all directions. Structures like the great attractor and the dark flow are a clear violation of this principle on local scales of hundreds of millions of light-years. The key question is, how large does a scale have to be before the universe becomes truly smooth? The shadow helps us answer this. By measuring the extent of its influence, we can determine the scale at which local, peculiar motions become insignificant compared to the overall cosmic expansion. The shadow is the local weather, and by charting its boundaries, we can begin to see the calm, global climate of the cosmos as a whole. Let us imagine the shadow's core not as a place, but as a state of being. It is the state of maximum gravitational binding, a place where matter has reached its final, most stable configuration. The journey towards the shadow is a journey of spiritual, as well as physical, settling. It is a process of releasing the stored potential energy of our cosmic separation and finding a state of rest in the deepest part of the landscape. This can be a powerful metaphor for a meditative practice. The goal is to quiet the cosmic expansion of the restless mind and allow our awareness to settle into the great attractor of the present moment, a state of deep, stable, and peaceful being. The shadow is the universe's own meditation, a 13.8 billion year-long process of settling into itself, and we are privileged to be a part of it. The shadow forces us to think about the universe as a nested hierarchy of systems. Our planet is part of the solar system. The solar system is part of the Milky Way. The Milky Way is part of the local group. The local group is part of the Laniakea supercluster. This nested structure, with each level governed by its own dynamics but influenced by the level above it, is a hallmark of complex systems. The shadow represents the highest, most dominant level of this hierarchy in our local universe. It is the CEO of our cosmic corporation, setting the overall strategy and direction for all the divisions beneath it. Understanding our place in this cosmic organization chart is a key part of understanding our own context, a realization that we are part of a system of systems, a beautiful and intricate clockwork of nested gravitational influence. The very darkness of the shadow is a source of its profound beauty. In a universe saturated with the brilliant light of stars, the shadow is a region of quiet, contemplative darkness. It is a testament to the fact that the most powerful things are not always the brightest. Its power is subtle, invisible, and inferred. This appreciation for the power of the unseen, the beauty of the void, is a sophisticated and deeply calming aesthetic. It is an understanding that silence can be more powerful than noise, that emptiness can be more meaningful than fullness, and that the greatest stories are often told not by what is there, but by the shape of what is absent. The shadow is the great absence that gives shape to our local universe, the defining darkness that makes the surrounding light all the more precious. The shadow is a cosmic lesson in the difference between complexity and complication. Our daily lives are often complicated, filled with a tangle of urgent but ultimately trivial demands. The shadow, on the other hand, is immensely complex, but it is not complicated. Its behavior is governed by a few simple, elegant physical laws. Its complexity is emergent, arising from the interaction of countless simple components over vast stretches of time. This is a profound distinction. The shadow reminds us that true elegance and beauty often arise from the patient application of simple principles, not from the frantic management of complicated details. It is an invitation to seek the simple underlying principles in our own lives, and to trust in the power of slow, patient, and emergent growth. The shadow provides a powerful, unifying narrative for all of humanity, and indeed for all life on Earth. Every culture, every nation, every living being on this planet is a passenger on the same cosmic vessel. We are all bound by the same gravitational tide, heading toward the same mysterious destination. The shadow's pull is a force that is completely indifferent to our terrestrial divisions. In the face of its immense shared influence, our differences seem small and insignificant. It is a cosmic perspective that can foster a sense of unity and shared identity, a realization that we are all, quite literally, in this together. We are the crew of Spaceship Earth, and our ship is on a grand centuries-long voyage across the Laniakea supercluster, a journey set for us by the silent, growing shadow. The shadow is the ultimate long-term investment. The universe, through gravity, invested a tiny amount of its initial energy in the slight overdensities that would one day become the shadow. For 13.8 billion years, this investment has been compounding, slowly but surely growing into the colossal structure we see today. It is a perfect example of the power of compound interest, applied on a cosmic scale. This is a deeply optimistic process. It shows that the universe is not just expanding and thinning out into nothingness, it is also investing in pockets of structure, building up cosmic capital that will serve as the engine for future complexity and perhaps future life. The shadow is the universe's most successful hedge fund, and its growth is the dividend that we are all privileged to witness. Let us contemplate the final quiet state of the universe. In the far, far future, after all the stars have burned out and all the black holes have evaporated, the universe may enter a state of near total darkness and emptiness, known as the heat death. But even in this state, the memory of the shadow may persist. The final, stray photons and particles will still carry the faint imprint of the gravitational potential of the structures that once existed. The ghost of the shadow may be the very last discernible feature in the cosmos, a faint statistical anomaly in an otherwise featureless void. Its influence is so profound that it may be the last thing to fade away, a final, whispered echo of the great, structured, and beautiful universe that once was. The shadow is a humbling check on our intellectual arrogance. We have built a remarkably successful model of the universe, the Lambda CDM model, that can explain a vast range of observations. Yet, at the heart of this model are two components, dark matter and dark energy, that we do not understand at all. The shadow is a structure made primarily of one of these mysteries, dark matter, and is fighting a battle against the other, dark energy. It is a constant, unavoidable reminder of the vastness of our ignorance. It is the physical embodiment of the known unknowns that lie at the frontier of our knowledge. To study the shadow is to stare into the face of our own profound lack of understanding, an experience that is essential for true scientific progress and deep intellectual awe. The shadow is a perfect object for a guided meditation because its properties align so well with the goals of mindfulness. It is constant and stable, like the breath. Its pull is gentle and non-judgmental. Its existence encourages a broad, open perspective, a sky-like awareness. It connects us to a reality that is larger than our own ego. It is a physical anchor for the abstract concepts of deep time, interconnectedness, and impermanence. By focusing the mind on the shadow, we are not engaging in an empty fantasy. We are aligning our consciousness with the deepest and most fundamental truths of our physical reality. It is a way of grounding ourselves in the cosmos, of finding our place in the grand, silent, and ever-flowing river of existence. The language we use to describe the shadow is ultimately inadequate. Words like attractor, pull, and flow are metaphors borrowed from our terrestrial experience. They are useful, but they fail to capture the true nature of a phenomenon that is about the geometry of space-time itself. The shadow is not pulling us through space. It is simply that the path of straightest motion through the curved space-time of our universe leads us toward it. We are not moving. We are following the contours of the world. This more accurate but less intuitive description highlights the limits of our language to describe the cosmos. The shadow exists in a realm of pure mathematics and physics that our poetry can only approximate. Its true beauty lies in its silent geometric elegance, a truth that can be felt and understood, but never perfectly expressed in words. The shadow is a cosmic Rorschach test. What we see in it often reflects our own philosophical predispositions. An optimist might see it as a force of cosmic creation and community building. A pessimist might see it as a relentless destroyer of galactic identity. A mystic might see it as evidence of a divine plan. A physicist sees it as a natural consequence of gravitational instability. The beauty is that all of these interpretations can coexist. The shadow is vast enough and mysterious enough to accommodate a multitude of meanings. It is a mirror that reflects our own attempts to find order and purpose in a universe that is often silent on such matters. Its ultimate meaning is not something we discover, but something we create in the quiet, contemplative space it opens in our minds. The shadow is the ultimate ground of being in our local cosmos. In philosophy and theology, the ground of being is the fundamental source of all reality. In a purely physical sense, the shadow is this for our supercluster. It is the foundational gravitational structure upon which everything else is built. It is the source of the forces that guided our formation and the destination that determines our future. It is the alpha and the omega of our local cosmic story. To connect with the shadow is to connect with this physical ground of being, to feel the deep, underlying reality that supports and guides our existence. It is a profoundly grounding experience, a way of touching the very foundation of our world and finding a sense of unshakable stability in its immense and patient presence. Let us imagine the final moments of our galaxy's independent existence. After a journey of 100 billion years, the now merged Milky Way galaxy finally reaches the chaotic core of the Great Attractor. It is no longer a recognizable spiral, but a vast, bloated elliptical, its stars orbiting in random, disorganized patterns. It plunges into the dense heart of the cluster, a region crowded with other, similar galactic remnants. The tidal forces are immense, stripping away its outer layers and feeding them into the central gargantuan galaxy that dominates the core. The last vestiges of our galactic identity are erased. Our home becomes just another anonymous contribution to a larger whole. This is not an end, but a transformation, a final, complete surrender to the gravitational community that the shadow has spent eons building. The shadow is a cosmic lullaby. Its story is one of slow, gentle, and inexorable motion. Its rhythm is the patient beat of deep time. Its melody is the silent harmony of 100,000 galaxies, all moving as one. It is a story that does not have sharp turns or sudden surprises. It is a narrative of profound stability and predictability. Listening to this story, internalizing its rhythm, is a deeply calming experience. It soothes the anxious mind and quiets the restless heart. The Shadow's Tale is the perfect story to hear before sleep, a cosmic bedtime story that gently rocks us into a state of deep rest, carried along by the slow, majestic, and utterly peaceful current of the universe. The Shadow, in the final analysis, is a story about belonging. In a universe that can often feel cold, empty, and meaningless, the Shadow reveals a hidden layer of connection and order. It shows us that we are not alone, that our galaxy is part of a vast and ancient family, a cosmic clan bound together by a shared history and a common destiny. We belong to Laniakea. We are being guided by the shadow. This sense of belonging is a fundamental human need, and the universe, in its strange and beautiful way, provides it. The shadow is the ultimate confirmation that we are part of something much, much larger than ourselves, a system of profound elegance and sublime beauty. To feel this belonging is to feel at home in the cosmos. As our journey of contemplation comes to an end, let the feeling of the shadow remain. Let it be a quiet hum in the background of your awareness, a sense of a deep underlying current that is always present, always gentle, always guiding. This feeling is one of deep peace, a peace that comes from understanding and accepting our true place in the universe. It is the peace of a small boat that has finally stopped fighting the current and has instead decided to enjoy the long, slow, and beautiful journey downstream. The destination is far away and shrouded in mystery, but the journey itself is calm, steady, and shared. There is nothing left to do but to trust the flow. The shadow grows, and we are carried with it. This is the simple, profound, and inescapable truth of our cosmic existence. It is a truth that can be a source of fear or a source of immense, meditative calm. The choice is ours. By choosing to see the beauty, the order, and the sublime majesty in this process, we transform a cosmic fact into a spiritual practice. We turn the cold physics of gravity into a warm blanket of cosmic belonging. The shadow becomes our guide, our anchor, our constant companion in the vast, silent darkness. Its silent pull becomes a gentle hand, leading us not just across the universe, but into a state of profound and restorative peace. And now, there is only the quiet of deep space, punctuated by the slow, silent wheeling of the stars. There is only the darkness, a deep, velvety black that holds all of creation in its gentle embrace. There is only the motion, a smooth, effortless, and unified flow toward a destination beyond the horizon of our understanding. In this quiet, in this darkness, in this motion, there is a profound sense of rightness, a feeling that everything is exactly as it should be. The mind can rest, the body can soften, and the spirit can float free, secure in the knowledge that it is a part of this grand, silent, and beautiful cosmic drift. The story is told, the journey is underway, the shadow pulls, and we, in our smallness, in our brief and precious moment of awareness, are a part of it all. Let the great, slow current of the cosmos now carry you into the deep, silent, and star-filled ocean of your own rest. There is nothing to hold on to, nothing to resist. Simply let go, surrender to the gentle gravitational pull of sleep, and know that as you fall, you are falling with 100,000 galaxies, all held safely in the arms of the great and ever-growing cosmic shadow. Sleep now. The universe is taking care of the rest.